A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of climatology, where, as we move ahead, today we shall be talking about the various different atmospheric phenomena which does impact the global climate. And these are the atmospheric phenomena which eventually also end up influencing Indian climate. And that is why these particular atmospheric phenomena are something that we are going to study. This is relevant for your prelims. Few of them are relevant even for your mains examination. Now, many of the portions that we will study here, that is something that you won't find to be present in the reference books or in the NCRTs. So that is why the PPTs, again, in this case, should serve as a point of reference for your overall studies. Now, in this particular portion, we shall be studying about the Walker circulation. We shall be studying about the factors of upwelling, downwelling. What do we understand by the Enzo cycles, El Nino, La Nina conditions? When is it that a La Nina condition occurs, or what is it that we refer to as a La Nina? What is it that we refer to as El Nino? Then we will be studying about a kind of a similar phenomena which exists in the Indian Ocean region, that is the Indian Ocean dipole. We shall be studying about the traveling pressure belt system in the form of the Madden-Julian oscillation. And then after that, we shall be also studying about the jet streams. As I told you yesterday also, in order to understand this particular concept, the understanding of the tricellular model of atmospheric circulation is very, very important, right? Now, that will form the basis of our understanding of many of these phenomena as we move ahead. Now, when we talk about the portions relevant for the prelims, so for the prelims, you can expect questions about the Walker circulation, the Enzo cycles or Enzo basic features, Indian Ocean dipole, dipole. Then after that, the portion about Madden-Julian oscillation, the absolute basics. And then jet streams. Okay. And when we talk about the portions relevant for the mains examination in this case, Enzo, their basic features, and also jet streams. From these areas, questions have been framed and questions can be framed again going ahead into the future. Now, when we initiate the discussion, first of all, we shall again be revisiting some of the concepts about the pressure and about the rise and the fall of the air mass. You have to understand that this is amongst the final conceptual portions that you come across. After this, we will come across the portion of Indian monsoon, and that will be the eventual conceptual portion. And after that, mostly it is easier to go through, and it is the rest of the portion is quite easier to comprehend. So, here, when we talk about the entire rise and fall of air parcel, till now, when we have seen the rise and the fall of the air parcel, we do know that whenever you have a difference in temperature in between two different areas, you have a relative high pressure and low pressure which gets created, right? When we talk about thermal pressure, the conditions of thermal pressure, so wherever you have a relative high or a low temperature, relative difference of temperature creates high pressure and low pressure conditions. And we do know that winds always will blow from a high to a low, always, right? Always the winds will be in motion from a high pressure to a low pressure region. Now, we also saw the atmospheric circulation which does happen across the planet Earth. And in terms of the atmospheric circulation that we have seen, that we have studied till now, one of the common features of that atmospheric circulation has been that from one particular latitude, the air parcel has risen up, it has basically sunk in other particular region of the latitude, right? So this is a kind of a circulation that we observe, which does occur in between the places of different latitudes. Having said that, you had a climatologist in the name of Sir Gilbert Walker. Now, Gilbert Walker was an accomplished climatologist of his times. Now, Gilbert Walker, while he was studying the region around Pacific, he was absolutely convinced that in the entirety of the wide region of Pacific, the Pacific being so very wide and so very large, particularly around the central region of the equator, he was convinced that different ends of the Pacific, over a period of time, they end up indicating different temperature. And thereby, he thought about it that there must be a circulation in existence at the same latitude. Okay. There must be a circulation in existence at the same latitude rather than in different latitudes. And that is what brought about the existence or the discovery of the Walker circulation. So Gilbert Walker was the one who basically postulated the Walker circulation to be in existence. But he was also very sure, and he was not sure why and how, but he was significantly sure, basically, that when we talk about the Indian monsoon and the Indian climate, they are also influenced by this circulation which happens across the region of Pacific. It is because of his this conviction that eventually he took a posting. Excuse me. It was basically because of this conviction of his that he took a posting with the Indian Meteorological Department in the late 1800s and the early 1900s. He basically took a posting with the Indian Meteorological Department. He also served as the head of Indian Meteorological Department in order to further his research and in order to further carry out the research that how the warming and the cooling of the Pacific or the circulation in the Pacific, how will they end up influencing the Indian monsoon? It is a different matter altogether that he could not carry out any further research or he could not prove the linkage between the Walker cell and the Indian climate. But then later on, the later climatologists, they did prove a relation to be in existence, where we do know that whenever you have conditions of El Nino, the amount of rainfall in India tends to reduce. Whenever you have the conditions of La Nina, the amount of rainfall in India tends to increase over a long-term average. So, here, first of all, we shall understand what do we mean by Walker cell or a Walker circulation and why does that happen? Now, before we come into the portions of the Walker cell and the Walker circulation, some of the very basic concepts that you should be aware of or you should ideally know about, that is about the oceans. Now, when we talk about the Walker cell, El Nino, La Nina, all these conditions that you have heard about, these are basically the events which occur in the Pacific Ocean, which influences the air circulation above them, right? So all these things about El Nino, that this is going to be an El Nino year, this was a La Nina year, all those portions that you come across, these are virtually the circulations which are initiated by the properties of the Pacific Ocean, and more particularly so, the central southern region of Pacific. Now, when we talk about the oceanic area, when we talk about the oceanic region, so what do we have in the case of the oceans? We do know that these oceans, let's suppose we consider the ocean in any tropical portion, any tropical part. Okay. Now, here, what is the source of heating when it comes to the oceans? The main source of heating for the oceans, it is the solar insolation, right? It is the solar insolation which provides that heating. That is the source of heating for the oceans. Now, if that is the case, if the solar insolation is the source of heating, then we can say something about the temperature here of the water, the horizontal distribution of temperature. We do know that the topmost layer will be the warmest layer of water, and as we go into the lower regions, the temperature will start to reduce. So here we have subsurface cooler water. So water below the surface is slightly cooler. Water on the surface is significantly hotter and is significantly warm. Now, this is one of the properties that we do know about the ocean temperature and the variation in ocean temperature, right? So we do know, we can have a conclusion that temperature in tropical regions, oceans, is highest on the surface and reduces with depth, because the intensity of solar insolation will also reduce as you move into the depth of, let's suppose, the water body. The amount of heating caused by the solar rays will also reduce, right? So reduces with depth. That is why the temperature of the water on the surface is always going to be highest, and the temperature of the lower regions is always going to be comparatively lower. Okay. Now, then we come across another concept of movement of winds above the water. So let's suppose here we consider a large water body, a large ocean for that matter, with the both ends of the ocean indicated here, both the coastline of the oceans indicated here. Now, if I say that there is a strong wind moving in this direction, and listen to this very carefully. If I say that there is a strong wind moving like this, so if the wind is moving, and by the way, if it is moving over the water bodies, anyways, the wind will gain some speed, because over water and above water, you don't have that much amount of frictional force. So the wind will be particularly fast, isn't it? Now, here, as the wind is moving with significant speed, it will carry some amount of surface water along with it. It will drag some amount of surface water along with it, isn't it? Why? Because as the wind is moving against the surface, due to the air drag, it will be able to carry some amount of surface water along with it. Now, surface water is the warmest layer. So, there we can say that the wind is going to drag away the warmest layer of the water. Now, what happens if the wind drags away the top surface of the water? Think about it. What will happen? Either in that region, there will be a reduced depth of water, the height of water level will reduce, or you will have water from below, the subsurface water, which will rise up to replace the one which has been dragged away. What do you think will happen? If the wind is moving with a substantial speed, dragging the surface water along with it, what do you think will happen? Will the water level decrease, or will there be a kind of a subsurface water refilling that region? What do you think? It will replenish. Very good. So, as the surface water is getting dragged away, as here the surface water is getting dragged away, you will have colder subsurface water from below, which will rise up. The colder subsurface water from below will rise up and replace that. Right. So, what can we say about the ocean temperature in this particular scenario? The ocean surface temperature, what can we say? We can say that as the warmer water was carried away, eventually the subsurface water has replaced this. Subsurface water being colder, here the surface temperature will reduce, isn't it? So, here with the upwelling, upwelling means the upward motion. The subsurface water is indicating an upward motion, right? With the upwelling of subsurface water, the surface temperature reduces, right? Now, here, whenever you have such an instance where water from the lower region rises up due to the movement of the wind, etc., where you have the water of the lower region rising up and replacing it on the surface, that is an upward motion of water. And that upward motion of water, that is what we refer to as upwelling. Okay, I'll give you the written definition of it as well, so don't worry. So, as you have the subsurface water which starts rising up to replace the surface water, that is what we refer to as upwelling. Meanwhile, as these winds move, they will be carrying and dragging the surface water along with them. All these winds, they will be carrying and dragging the surface water along with them. Now, all this surface water which is being carried all across this region, where will that surface water go? Will the winds lead to the flooding of the land? No. Here, all that water starts getting piled up, eventually has to be pushed down, right? Eventually, the water will have to be pushed down because more water is coming on the way. So, along with the pile up, that water is continuously pushed down. So, here, all that warm surface water has accumulated in this area, and that water slowly and steadily is pushed down into the lower region. So, that is a downward motion of the water, and that is what is referred to as downwelling. Now, by the way, what can we say about the surface temperature of the ocean in this area? What can we conclude about the surface temperature of this area? As you have the piling up of the surface water, what do you think will happen? Will the temperature remain consistent? Will the temperature increase as compared to the previous scenario? Or will this region experience a decrease in temperature? Very good. On this region, on the surface, As you have piling up of the surface water, this will lead to a higher temperature. Surface water is the hottest water here. So that is why, due to piling up of surface water, temperature at the surface increases. Okay, so this is something about how the winds, they can end up influencing the ocean temperature in an area. So generally, when the winds are offshore, they are moving from land to the sea, they will be dragging the surface water away along with them. And as they drag the surface water along with them, the lower subsurface water rises up to fill that vacancy, and the lower subsurface water being colder reduces the surface temperature of the ocean. But this rise up of the subsurface water, that is what is known as upwelling. Now, when you have a condition where the winds are onshore, for example, moving from sea to the land, now they have been dragging all the surface water along with them. Now, where will they take the surface water? Do you think that onshore winds will keep on bringing the ocean water into the land areas? No, that does not happen. So, where will that surface water go? Eventually, it will be piled up, and by the pressure of the piled up water, the surface water will eventually have to be pushed down. So that is downwelling. So in this case of downwelling, we experience a piling up of surface water. And because the surface water is the warmest region, that is why you experience an increase in temperature. So here what we have seen is that at the two ends of the ocean, due to the movement of wind, at the two ends of the ocean water can indicate different temperatures. They can indicate a variation in temperature. Here you can have lower temperature, here you can have a kind of a higher temperature. And that is purely because of the movement of wind as experienced over these oceans. Now, after this, we come to these particular portions. Now, then we come to the portion of Walker circulation. Now, when you have this Walker circulation, something very similar ends up happening in this region. So, let us understand that. What do we mean by Walker circulation? First of all, let us get that clear. So, here, let's suppose this is your equator. Let's assume, right? Even though it is slightly higher up, but let's assume this is your equator. Now, when we talk about the equator here, near the equator, which permanent wind system is in place? Which particular permanent wind system will be in place in the region around equator? The trade winds. Very good. So when we have these trade winds, what is their direction of motion? The trade winds will be moving like this in the northern hemisphere. Right? They will be moving like this. And same is the case in the southern hemisphere also. These are your trade winds. Right? Now, if I think about the direction in which the trade winds are moving exactly around the region of equator, let's suppose I think about the direction in which the trade winds are moving around the equatorial area. What is the direction that you see here around the region of equator? What is the general direction that you see here? East to west, right? The general direction that you observe is kind of east to west. Now, these winds are blowing over a very vast area. Pacific Ocean, the largest ocean of the world, is a very vast area. So, in the region of the Pacific, as these winds are blowing, what do you think will happen? They will also carry the amount of surface water along with them. The surface water, being the warmest layer, will be dragged away by the wind. So here, let's suppose the surface water from this region, from this area, is getting carried away. Surface water from this area is getting carried away. Now, as the surface water is getting dragged away from here, there will be piling up of surface water. Where? In this area. The surface water will get piled up, will eventually get pushed down in this region. Also, downwelling will also happen to some extent. But you will have piling up of surface water from the entire region of Central Southern Pacific into this particular area. And you know, if you are interested to know this, that the winds, the trade winds in the Pacific, in reality, they pile up the surface water in the western part of Pacific to such an extent that basically the water level in the western Pacific rises by around 10 centimeter, 8 to 10 centimeter in certain instances, right? But before that, let me be very, very clear. Many of you have a lot of confusion with direction, regardless of the age. Still, you have a lot of confusion with the directions. So when we talk about Pacific, this is your Western Pacific. This is the portion of the Eastern Pacific. Okay, so don't get confused in that. That western part of South America you are saying is eastern portion of Pacific. It should be. Don't get confused like that. So this is your eastern portion of Pacific. This is your western portion of Pacific. Now, as I was telling you, in reality, when these winds, they basically blow, these winds, they will be carrying all the surface water, dragging all the surface water, and all that surface water piles up, creating a height difference of about 8 to 10 centimeter, where the seawater level in the Western Pacific rises by around 8 to 10 centimeter. Now think about it. Under normal circumstances, if you think about 8 to 10 centimeter, it is not very much. Even your smaller plastic ruler is of 15 centimeter. So what will that difference of 8 to 10 centimeter will create? But that is huge. In terms of the oceans, there the water level is almost consistent. If you have this much of a height difference, that is humongous. So that is why it is a kind of a huge pile up. Now, in the meanwhile, as the surface water from the region of Eastern Pacific has been dragged over, the subsurface water in this region will rise up, isn't it? Upwelling will be in feature. So that is basically the here the subsurface water will rise up on the surface. Right? So here you have upwelling leading to the rise of upwelling leading to the rise of cooler subsurface water. Okay? Now here you have the pile up of the warmed up surface water, right? So in this region you have a kind of a pile up or accumulation of surface water. Now, what can we say about the temperature at both ends of the Pacific? We do know that this will have a higher temperature, right? This will have a kind of a high temperature. High temperature means a low pressure. Right? A thermal low pressure. Meanwhile, in the region of Eastern Pacific, you will have low temperature, lower in comparison to the western part of Pacific, lower temperature leading to a kind of a high pressure. So at both ends of the Pacific, you have a difference of pressure which gets created. A pressure gradient gets created. Now, winds always will blow from a high to a low. We do know that fact. That winds will always be in motion from the region of a high pressure to a region of a low pressure. So here also, the winds will come into motion. And the winds basically will come into motion like this. It will be a kind of a strengthening of the trade wind system in itself, where the winds will simply and straight away blow towards the region of this warm temperature. From both ends, what the winds will come here. Now, once the winds come here, then after that, what happens? They will also get heated up. They will rise up. Right? They will rise up. Now, these are moist winds, which are actually rising up. So here you will also experience significant cloud formation, right? Here you will experience cloud formation to happen as well. And this region of Australia, Indonesia, Philippines, right, Papua New Guinea, all these areas will end up receiving copious amounts of rainfall. Then this air will further rise up till the region of tropopause. That is how eventually the circulation is completed. And this circulation, this wind will then diverge. One goes towards the Indian Ocean, other comes towards the region of the Pacific. This will then end up sinking in the region of the high pressure. Right. So you see here a circulation in place which occurs at the different places of the same latitude. Till now, what we have seen is that 0 degree will have a kind of a low pressure, 30 degree will have a kind of a high pressure, 60 degree will have a low pressure, then 90 degree will have a high pressure. So we have a latitudinal difference of pressure that we have studied till now. But here what you observe is across the same latitude, you have the different pressure systems which build up. So across the same latitudes, you come across or you end up observing this kind of a circulation where a low pressure gets created in the Western Pacific due to the piling up of the surface water. Why is it that there is a piling up of surface water in the Western Pacific? Because as the winds are blowing from east to west, they shall be carrying the warmer and the warmest surface water along with them. And owing to the land areas and the land barriers in the region of the Western Pacific in form of the various islands, that water simply does not flow into the region of Indian Ocean, but it continues to keep on getting piled. So if you think about it, and if you have a doubt that piling is also happening, how come downwelling will also happen? Understand, downwelling is what is the downward motion of water. The rate at which the water is pushed down is not the same rate at which, it is not as if the wind is bringing this water, it will be pushed down, then the next water will be brought out, it will be immediately pushed down. No, lighter water or warmer water is going to have less density. Anything which is warm is going to have lesser density. So as that warm water is brought into the region of Western Pacific, it begins to pile up, and it begins to pile up on the surface because it has got lower density, it is warmer, it doesn't want to sink down. But more and more water is continuously being brought by. So slowly and steadily, some amount of that surface water will be pushed down there. That is why downwelling and piling can go simultaneously here. But nonetheless, in the region of the Western Pacific, because of all that surface water which has been accumulated, you will have the warmer temperature because the surface water is the warmest layer. So there, the piling up of surface water creates a high temperature, and that creates a thermal low pressure. In the meanwhile, in the region of Eastern Pacific, that is across the South American coastline, as the surface water is being carried away by the wind, that creates a vacancy which is filled by the cooler subsurface water. So there you have a cooler temperature or a considerable high pressure. Now, because of this, you have a kind of a circulation pattern between the eastern and the western ends of the Pacific. And that circulation pattern is what we refer to as the Walker circulation or Walker cell. Okay, so when we talk about Walker circulation, it is the kind of longitudinal or east to west circulation across the equatorial Pacific, and that is known as Walker cell or Walker circulation, right? Now, this will lead to different climatic conditions. For example, in the region of Indonesia, Philippines, the islands of the West Pacific, Australia, this will lead to heavy amount of convectional rainfall. Whereas, what about this region, the Peruvian coastline and the South American coastline? These areas, under normal conditions, will be dry because you have sinking air. So that is why, because of this reason, under normal situations, this is the circulation which you witness. That is why the Peruvian coastline, western coast of South America, that is comparatively drier. Whereas when we talk about the eastern coast of Australia, Indonesia, Philippines, they continue to receive significant amount of rains in the process. So this is a kind of a circulation pattern which you observe here. This is a kind of a schematic cross-sectional view. So here you observe, and observe this carefully. Observe how the trade winds, they are carrying the surface water along with them. So here, the cold subsurface water rises up to compensate it. Whereas you have the warm water which starts getting accumulated, some of them forcibly are getting pushed down across the western end of the Pacific. So here you have a low pressure, here you have a high pressure. So that is what brings about a circulation where across the Australian coastline we receive rainfall, whereas across the Peruvian coastline you have dry conditions, right? This fair WX is basically fair weather conditions, right? Don't get confused with WX. WX here refers to weather condition, right? So this is your Darwin coast and this is your Tahiti Islands, which is in the central portion of the region of Pacific. So that is basically your Walker circulation which happens. So here across the same latitude this happens. So that is why it is also known as longitudinal, because it happens across different longitudes, right? So trade winds blow from a general direction of east to west. Okay, now the winds blowing over the vast expanse of the Pacific end up gaining a higher speed. Now these trade winds tend to drag some amount of surface water along with them. These surface waters are warmer due to solar insolation. As these warmer waters accumulate, that creates a condition of low pressure where in Western Pacific, right? Low pressure in Western Pacific leads to a kind of Walker circulation is initiated as a consequence of this, where the regions of the Western Pacific, they receive rainfall, whereas the regions on the eastern side of the Pacific, that is South American coastline, they are rendered to be drier. So this Walker circulation, as you can see, will have its influence and impact across the central equatorial regions of the planet. Now, this is different from your Hadley cell, Ferrel cell, and the polar cell that you came across, right? We have seen already that these Hadley cells, polar cells, etc., rather you don't have the pressure belts, you have the pressure zones. Okay, so here you will have a kind of a circulation which is initiated almost across the same latitude. So here this is the impact of the Walker circulation. So observe under these conditions, you have the presence of sinking air, right? In this entire region you have the presence of the sinking air. Here you have a rising air column on the Western Pacific. This creates a heavy convective cloud condition. Very heavy convective clouds brings copious amount of rainfall. Observe this region around the region of Arabian Sea and Western Indian Ocean. Now around this area, you observe you have a sinking air column. That means this region will be high pressure or low pressure. It will be a high pressure. Now, ideally, when we talk about events such as formation of a cyclone, a tropical cyclone, we studied yesterday that the conditions required for the formation of a tropical cyclone is a warm sea surface temperature with a condition of a pre-existing low pressure area. In the water, if you have a pre-existing low pressure area, chances are that a tropical cyclone, it can intensify into tropical cyclone. Now, here, as compared to the Arabian Sea and Bay of Bengal, Which is the region more likely to witness a cyclone? Arabian Sea or Bay of Bengal? What do you think? More likely to lead to the formation of a cyclone? Good. It will be the Bay of Bengal, because here you have a high pressure. In high pressure conditions, Arabian Sea, how will it lead to the formation of a cyclone? Right. So, under normal circumstances, that is why Bay of Bengal is more suited for the formation of a tropical cyclone. That is why we witness large frequency of tropical cyclones getting created in the region of Bay of Bengal. Okay. Now, after this, we talk about the portion of upwelling and downwelling, where we have seen that whenever you have the surface winds in such a direction, let's suppose from the coastline, as the winds they blow, now they will carry the warmer surface water along with them, and the subsurface colder water that rises up to the surface, right? Now, this upwelling, whenever and wherever in whichever oceans they are caused, this upwelling is also beneficial for the fisheries. Why? Because when you have the colder subsurface water coming up, colder water coming from the lower regions of the oceans, they bring along with them many of the nutrients such as iron particles, etc. Many of the nutrients are brought closer to the surface. Now, in the presence of nutrients and in the presence of sunlight closer to the surface, planktons, they start to grow. The plankton population, planktons are basically algae, right? Microscopic algae and algal species. Now, these algal species, they utilize the availability of sunlight, and these algal species utilize the presence of nutrients, and then they are able to carry out photosynthesis. Whenever you have an increase in the algal population, the zooplanktons increase, the fish population increases. So you have an increase in the amount of or the number of fishes there. So that is why in the regions of upwelling, generally you will find that deeper, colder, nutrient rich water which comes up is ideal for the growth of planktons, and that feeds into the marine food chain, which is good for the fisheries sector also. So these are your good fishing grounds which are there. Okay. So if you take a look at the definition of it, so winds blowing across the ocean surface push the water away. Water then rises up from beneath the surface to replace the water that was pushed away. This process is known as upwelling. Upwelling occurs in the open oceans and also across the coastlines. In the reverse process called downwelling, that also occurs when the wind causes the surface water to build up along the coastline, and the surface water eventually sinks towards the bottom. That is when you have the pile up of the wind, and that pile up of the water eventually is pushed in the downward direction. So that is what your concept of upwelling and downwelling are. Okay. Now, after this, we come to the concept of El Nino, Southern Oscillation, or ENSO. Now, when we talk about ENSO cycles, is Walker circulation one of the reasons behind Atacama Desert? No, Musharraf. You have Atacama Desert, which actually exists quite significantly to the south of it. So, and Atacama, mind you, has been a desert for a very long time. Even before South America split from the region of Africa, even before that, Atacama has been a desert. It has been a desert for millions of years, right? And in this particular situation, it is the cold ocean current near the west coast of the South American region, as we will study when we come to the portion of oceanography. Now, that is the force which is responsible for the creation of the Atacama Desert. That is why in the western margins of the continents, be it the Victoria Desert, be it the Kalahari Desert or the Namib Desert, be it the Mojave Desert. So in the western coastline of the continents, you will always find the existence of deserts, right? And that has got something to do with the, again, interaction of ocean water and the air temperature, which we will cover in the coming modules. Okay. Now, after this, we come to the concept of El Nino Southern Oscillation, or ENSO. What is this? So, as we have seen, under normal conditions, Walker circulation is in existence. Under normal conditions, the Peruvian coastline, the coastline of Peru, that is in the eastern Pacific, under normal conditions, it will be dry because that is a region of high pressure. Now, when we are talking about the southern hemisphere, when is it that the summer season comes? During this time of the year, that is when they experience the summer season, isn't it? During the months of November, December, January, February, that is when the southern hemisphere experiences the summer season. So the Peruvian coastline and some parts of the West South American coastline, generally they would be dry during the summer. I hope we are able to follow up till now that the Peruvian coastline would be dry during these months. Now, as the story goes, that the fishermen across the Peruvian coastline, once they were out fishing, and suddenly, during the month of December, actually, around the time of the Christmas Eve, they went out fishing and they basically experienced sudden occurrence of rainfall. They were surprised because the month of December in the region of Peru is supposed to be dry, but they experienced sudden onburst of rainfall. Now that got them thinking, and they thought about it, as generally is the case with the human mindset. They thought about it that this must be the gift from God. And that is why they named this phenomena of sudden occurrence of rainfall in the month of these December months in Peruvian coastline and in the Peruvian region, they named it as El Nino. That is the Christ child. Right? So that is why they named this feature as El Nino. And basically, the observation was that every few years, every 5 to 6 years, or every 4 to 7 years, you have sudden aberration or a sudden anomaly where the Peruvian coastline, rather than being drier, it starts receiving high amount of rainfall. And otherwise, under normal conditions, it would be dry, won't receive much rainfall. But then again, an year would come when the Peruvian coastline would receive a lot of rains. So basically, they thought that the climatic conditions in the region of Pacific, that is varying between Peru receiving heavy rainfall and Peru getting dry. So that is why they named it El Nino oscillation. But why the term southern? Southern here as a terminology is used because here all these events, they influence the regions immediately to the south of equator quite immensely. That is, the region of Australia, the region of Peru, etc. They are influenced quite frequently. And hence the name Southern Oscillation. Oscillation means what? Movement between two fixed areas, continuous movement, that is what is oscillation. Right? You would have observed the oscillation of a pendulum. It moves from one to the other extreme to the other extreme. That is oscillation. Right? So, the climatologists initially were absolutely convinced that you have two conditions. One condition where Peru does not receive that much amount of rainfall, and then the other condition where Peru, during these months of November, December, January, it receives heavy amount of rainfall. So they named it as El Nino Southern Oscillation. Later on, as the climatologists went there, the climatologists basically discovered that there is another weather phenomena which exists in the Pacific. And that is when Peru goes to the other extreme of excessive dry drought like conditions. Australia goes to the other extreme. So heavy rainfall that it creates floods. Exactly the opposite of El Nino. So they named that event as La Nina, or the opposite of El Nino. That is the girl child in literal translation. So that is why in the region of Pacific, when we talk about ENSO now, El Nino Southern Oscillation, we basically are talking about the variation between three different climatic conditions. One is El Nino, another is La Nina, another is neutral. conditions. And you observe a kind of a variation of climate from here. Sometimes it will come here, sometimes it will come here. So it keeps on varying from one type to the other and reverse. Right? So that is why, as the climatic conditions they keep on changing between these three areas, that is why it is referred to as El Nino Southern Oscillation. Okay? Is that understood till now? See, many of you have joined late. So, in that case, I cannot help you a lot in that case. But those of you who have basically been attending from the first minute, is that understood? Good. What is the reason for El Nino? We will come to it. Why that El Nino occurs, why that La Nina occurs, how does it influence India? We'll come to it. But till now, what we have talked about, what is Walker circulation, is that understood? What is upwelling, downwelling? Why is it that a difference of pressure gets created in both ends of the Pacific? Is that condition understood, or is there a doubt in that? Atacama Desert is a cold desert, my dear friend. Yes. Seema, is the story about the naming will be asked in examination? What do you think? If I put you in the shoes of the examiner, frame a question where you can have this kind of a story kind of a thing which will be asked. What do you think will be the kind of a question in that? Enzo consists of three phenomena: neutral, El Nino, and La Nina. Correct. Yes. And why in the months of December, Jan, and Feb only? That is when the southern hemisphere experiences the summer season. That is when these movements and buildup of temperature difference gets exaggerated in the region immediately to the south of equator. That is why. This diagram is not clear. This particular diagram. So this particular diagram, when you see here, so this represents that in some years it might be El Nino, then in other year it might be La Nina, in other year it might be neutral. So there is a kind of a variation from here to here or here to here. Okay. El Nino, we'll talk about it in detail once again. La Nina also we'll talk about in detail again. We'll talk about each of these in detail, each of these climatic conditions in detail, what is experienced in Australian coastline, what is experienced in the Peruvian coastline. Everything we'll be discussing about. But I just want to understand, is there any major portion that you feel a doubt about? Purva, what is the portion that you are uncomfortable about? And Jyoti, is there any particular problem that you can be helped with, or is that a general observation? Okay, you joined almost half an hour late, my dear friend. So then I cannot help you. Geography is very tough. It is. It is. I'm not going to stand here and say that this is the easiest subject out there, because I understand that you guys do read subjects such as many other subjects in this particular preparation, where you don't need to go into these depths. You have one book, you read that, all the questions are asked from this book only. uh, Chandrajyoti, no, if the PPT is you are thorough enough along with the current affairs, more than sufficient. So Lakshana, how to remember certain areas with their climatic conditions with map, repeat it as many times as possible. And Shalu, are you talking about the Somalian desert or the Solomon desert? Which desert are you talking about? And deserts generally are created due to high pressure. Always deserts. Wherever deserts are created, they are created due to high pressure. And in upwelling, the warm water carried out by the wind, and in western region, there will be pile up of warm water. Yes, that is true. And Lakshmi, is there topic? Is these topics relevant for prelims and mains? So today, let me make something very clear. Whenever we read any particular topic in this particular class, it is either relevant for the prelims or the mains. I will never even try to teach you certain topics which won't be asked in the examination. Okay, we are not here for pleasure or fun for geography. Let's enjoy the subject of geography. Obviously, if we are able to do that, fair enough. But we are all here to clear the examination, I hope. So, anything which is being covered in the class, trust me, only if it is being relevant for the prelims or mains, only then it is being covered. If we assume India as reference, Australia will be in Eastern Pacific and okay. No, Pratik, that is incorrect. Solomon Islands of US. So there are multiple reasons for that, but yes, high pressure is there. It also lies on the leeward side of the mountains, so that is also another factor. So now we delve deeper into this portion of El Nino Southern Oscillation, where we have seen that when we talk about ENSO, it is a condition of the variation in climatic conditions, or a kind of an oscillation of climatic conditions between a situation where Peruvian coastline receives very heavy rainfall to a situation where the Peruvian coastline is absolutely dry. Now, these normal conditions, so the neutral conditions, are nothing but a Walker cell, what we have studied as a Walker cell. Okay. That is your conditions which prevail normally across the Pacific, where the winds will blow from east to west. They will lead to piling up of water in the region of Western Pacific. Now, what happens under the normal conditions? Under the neutral conditions, again, this is a similar to Walker circulation, same as Walker circulation. So here, what do you observe? Trade winds, they help accumulate warm waters in the western equatorial Pacific Ocean, right? While the cold waters emerge in the eastern equatorial Pacific Ocean, always. Now, these cause rainfall in the region of northern Australia, while due to high pressure, there's a lack of rainfall across the western coast of South America, always. Okay, so it leads to high rainfall in the region of Australia. As we have seen earlier also, it will lead to, when you have a Walker cell, it leads to heavy rainfall in the region around Australia due to the low pressure created, and you have a fair weather and a dry condition in the region of Peruvian coastline. So here, when we talk about the neutral conditions, that is what is experienced, right? Lack of rainfall across the western coast of South America. So this is your neutral condition or normal condition. Okay, neutral or normal condition. Now, again, I want your attention for the next 4 to 5 minutes. Now, in these neutral conditions, what do you observe? That these trade winds, they are moving from the portion of Eastern Pacific to the portion of Western Pacific. But why are these winds moving from Eastern to Western Pacific? Because as these winds were initially blowing, they had carried the surface water, accumulated them in the region of Western Pacific, and in the Eastern Pacific, you had the cooler subsurface water which had risen up. That is why. Now, here you have a kind of a comparative high pressure, a kind of a comparative high pressure. Here you have low pressure. So you receive rainfall in the region of Australia, Philippines, Indonesia, Brunei, all these areas. Now think about it. If you have low pressure and high pressure, means what? You have pressure gradient, right? A pressure gradient force. Sometimes, and stress on the term sometimes. Don't forget this term sometimes. Sometimes, in certain cases, these winds, they continue to blow under these conditions, they continue to carry the surface water. Now, as they are carrying more and more amount of surface water, as these winds are more persistent, they will be dragging more surface water. They will be dragging surface water from this region also, from this region also, from this region also. In all these areas, you will have upwelling. So the colder subsurface water will get spread over this entire area. Isn't it? In certain instances, the colder subsurface water might get spread in the larger region also. Now, all that surface water which has been carried will lead to the larger accumulation of the surface warm water in a wider area. Right? The pileup will also increase. And here, as the removal of surface water is happening, more upwelling will also happen. So, what can we say about the intensity of low pressure and high pressure as compared to the normal condition? Will the intensity of high pressure and low pressure now increase? Or will the intensity of high pressure and low pressure now decrease? What do you think? Very good. Intensity of high pressure and low pressure is going to substantially increase here. Why? Because now you have a larger area of warm water, you have a larger area of cold water also, right? So if the intensity of high pressure and low pressure continues to increase, what can we say about the wind motion? Will the wind motion get faster? Will the wind motion remain the same? Or do you think the wind motion will get slower in this case? What do you think? Perfect. The winds will get faster, much more faster now. Now, as they get much more faster, winds are much more powerful. Can we say that they will drag more surface water along with them? If they drag more surface water along with them, what will you experience? Large areas of more warm water piling up and more areas upwelling being experienced, colder subsurface water rising up in this entire region. So, can we also say or look at it in another perspective? Can we say that this Walker circulation has been intensified? It has become much more intense. I hope everybody will agree that it is a kind of an intensification of the Walker circulation where the winds have become stronger, the low pressure has gotten much more stronger, the high pressure has gotten much more stronger, right? That is the condition which we refer to as the condition of La Nina. La Nina is nothing but an intensified condition of a normal Walker circulation. Because as the winds keep on blowing, they keep on accumulating that surface water and they keep on carrying that surface water and dragging that surface water, leading to upwelling. Observe here the extent till which the upwelling has happened. Almost the entirety of the region of Central Pacific and Eastern also, obviously, would have experienced upwelling of various degrees. And observe this warm water pool. This warm water pool is much more significant than what you had seen earlier. So, what this condition is nothing but an intensification of the Walker circulation. Now, if I say an intensification of Walker circulation, what about the climatic conditions? What about the region of Australia? Now, earlier Australia would receive rainfall. What about now? Now, the amount of downpour, the amount of rainfall will explosively increase, leading to floods, right, in many of these areas. Indonesia, very high amount of rainfall. Philippines, very heavy amount of rainfall. But what about the regions of South America? These areas. Under Walker circulation, they were dry. But what about now? When the high pressure has also become very prominent, they will experience almost drought-like condition. Very, very dry. No iota of rainfall at all. So that is known as the condition of La Nina, or the girl child. By the way, it is, see, ideally, it virtually makes no difference at all. But please don't pronounce it La Nina and El Nino just because it is not correct. It is Nina. The pronunciation is Ninya. Okay. So this is just to make you aware. I don't want my students or the students that I have had a chance of to interact with. I don't like it when the terminologies used are not perfect. So that is why let's go for La Nina. Now, when we talk about this, so here the region of eastern and northern Australia will receive very heavy amount of rainfall, right? So these portions of Australia will receive very heavy amount of rainfall, and the region of Peru will be almost cold, uh, will be almost drought-like condition. Now this is La Nina condition. This is also what is known as the cooling phase of the Pacific. Why? Because the larger portion of the Pacific you will observe due to upwelling, you have colder waters which are present, which have spread over the larger area. And why these cool waters have spread over? It is because from every area, as the surface water is getting dragged away, everywhere there is upwelling which is happening. So that is why this colder water region has actually spread. So this is also referred to as intensified Walker cell, Walker circulation. This is also what is known as cooling phase of Pacific. La Nina, by the way, is also beneficial for Indian rains, right? And I understand the curiosity will be kicking you very hard as of now, but then understand, we will study about it, that how La Nina impacts Indian monsoon in the next module, how El Nino impacts the Indian monsoon. We will study about it tomorrow. But as of now, just do with this much amount of information if you can, that La Nina always leads to increased rainfall in India. El Nino always leads to reduced rainfall in India. Okay. Now, let us take a look at this. So this is basically a kind of a circulation where accumulation of warm waters happens in the region of Western Pacific. So La Nina conditions are the conditions where a significant low pressure develops across Western Equatorial Pacific Ocean, while an intensified high pressure develops over the Eastern Equatorial Pacific Ocean. Eastern Equatorial Pacific Ocean, the region around the Peruvian coastline. In a way, it is an intensified Walker circulation, right? It leads to flood-like conditions across northern Australia, while leading to drought-like conditions across western part of South America. Okay, so that is your condition of La Nina. Now observe this particular image. I want you to look at it carefully, because here we are taking a look, we are going to take a look as the trade winds blow. Observe here, the surface water is almost carried away, and observe the amount of upwelling here. Here, all that warm water getting piled up, right, creating a high difference, and observe the warm water eventually getting pushed down. Convective clouds will be formed over the region of Australia, causing very heavy amount of downpour. But I want you to compare it with the conditions of what we observed earlier. So This one. This was a condition of a normal Walker cell. Look at the depth of warm water in this region and depth of warm water in this region under normal conditions. And when we say it is an intensified Walker cell, look at this one, where from the central and the eastern Pacific, all that surface water has almost been carried away, and you have the presence of very, very cold water in this area. Now, this will also have its impact, a circulation impact across the other parts of the planet as well. So, observe here, this is the La Nina conditions having an impact across the other parts of the planet. So, around the central Pacific, I hope you can see the colder waters they are spreading over, right? Here you have the warm water, significantly warmer water, and here you have the rising up. Now, here again, you have the sinking air in this region of Western Indian Ocean and the region of Arabian Sea. You have the sinking air column. So you have a kind of a high pressure created. So under these La Nina conditions, normally which region is going to experience more tropical cyclones to be formed? Bay of Bengal or Arabian Sea? Where do you think more tropical cyclones will be created there? Good. It will be in Bay of Bengal because Arabian Sea is experiencing sinking air, a high pressure. For the tropical cyclone, you need a pre-existing low pressure region. So that won't be present in the. So even under Walker cell, normal conditions, Bay of Bengal more suited for cyclone. Even under the conditions of La Nina, Bay of Bengal more suited for the cyclones. Now, we will come to the concept of El Nino. What is this El Nino, which has been creating a lot of havoc ever since a time immemorial? And El Nino, particularly, as and when we study and understand the impact of El Nino across the various parts of the world, curiosity increases. Even today, and I say this with utmost responsibility, even today, not much is known about the details of El Nino. We do know. Scientists are able to track it that this El Nino is happening. This time La Nina event is getting is expected, but they don't have the predictability of it. The climatologists, the meteorologists, the oceanographers, they don't have a predictability. They don't have the predictability that what will happen in the end 2024. They don't have the predictability that what condition can prevail in 2025. No, it will only be based on the observations that they make on a day-to-day basis, where they observe the temperature difference between Eastern and the Western Pacific. That is how they are able to estimate that, okay, this is an El Nino that we are experiencing, this is a La Nina we are experiencing, or this is the normal condition we are experiencing. But nonetheless, it is important and pertinent for us to understand the concept of El Nino. Now, in the normal condition and in the La Nina condition, in both these conditions, accumulation of warm water happens in which area? In the region of Western Pacific. I hope we are comfortable with that. That in all the conditions that we have studied till now, accumulation of warmer waters happen in the region of Western Pacific. We are comfortable with that. There is a pile up. I have also told you that there is a height difference also created, and height difference in water level you can observe by this also. There is a significant and a substantial height difference which gets created, isn't it? Now let us think about a simple homemade experiment. Now, let's suppose you consider a bucket of water. Yeah, okay, at your house. Now let's suppose you have filled this bucket to the brim, right? Now here, let's suppose you have installed a kind of a fan which is rotating, obviously, and it is blowing heavy amount of wind in this area. Now, here, what do you think will happen to the water? Water also, by the force of the wind, starts getting piled up here. In this portion, the water will get piled up. Some water might even spill over, but there will be a kind of a piling up of water. Here, there will be reduced height in this particular portion, and all that water will be pushed on the other side, right? I hope we are comfortable till now. Now, imagine due to power connection or anything, this fan gets switched off. This fan is put out of the equation. Then what? Will the water continue to remain in this state as it is? Do you think that still there will be a pile up in the other end of the bucket and there will be deficiency of water in one region? Do you think that will be the case? What do you think will be the situation? Will we observe a flow back of water where the water which was piled up will now flow back to its original position to gain normalcy? Right? There will be a flow back, isn't it? So the water tends to flow back, right? That is the condition that we observe. Something very similar happens in the region of Pacific also, where the wind emitted by the fan, which led to the accumulation, that can be thought to be very similar to the trade winds. The trade winds have actually led to the accumulation of warmer waters in the region of Western Pacific. All the region of Western Pacific, you have the accumulation of warm water because of the trade winds. What if, due to some condition or the other, for a temporary duration, the trade winds they disappear or they substantially weaken? Then what happens? Then all that accumulated water will start to flow back, right? It will flow back depending upon the pile up. It might reach the other extremity or it might accumulate in the central portion, but it will flow back, right? So when you have the weakening of the trade winds or sudden disappearance of the trade winds for a short duration, all that accumulated water in the Western Pacific tends to flow back. Now, here, the curious amongst you will always have this question, but why will the trade winds weaken? These are the permanent winds, planetary winds. Randomly, you are saying that they will get stronger, and randomly, you are saying that they will get weaker. What is this? So, why will the trade winds weaken? There's a reason behind that also. Just like in the case of a fan, the fan was the supplier of the wind. What is the source for the trade winds? Where do the trade winds originate from? Are we aware of that? I mean, we are aware, but are we able to recall that? Trade winds originate from the solar rays, ITCZ. They originate from the ITCZ and go where? Equator, ITCZ, insolation, rotation of Earth. Okay, okay. Westerlies. My question was, where is it that the trade winds originate? Trade winds, they come to the region of ITCZ, that is their destination. But what is the point of origin of these trade winds? Are we aware of that? Coriolis force, rotation of Earth, polar highs. Oh my God. Thank you, Satyam. Thank you very much. Subtropical high pressure belt. Thank you. Everyone else, please stop trying. That is, it is painful to look at these answers. I will give you the answer. Trade winds, they originate from the subtropical high pressure zone. Are we aware of that? Or is that a news story for us? We are aware of that? That trade winds, they originate from the region of subtropical high pressure, right? I will write it down also. That means absolutely no revision has been done for the tricellular circulation. Good. Trade winds originate from, but I understand that being a candidate is a very tough job, and basically the tensions of time is so immense. I'm sure at a level of prime minister and chief ministers, they have more time available with you with them as compared to you guys. So I understand the predicament here. Don't worry. Once you will come out of that phase, then you will realize that you had a lot of time, and basically it is a different matter. But nonetheless, so trade winds, they originate from the subtropical high pressure zone. And when we talk about this subtropical high pressure zone, can we say stronger the high pressure? Stronger the high pressure, stronger is the wind. Can we say this? Right? So that means we can also say weaker the high pressure, weaker is the wind. Comfortable with this? Right? I don't want someone to come 10 minutes later that repeat the entire concept from initial portions. Are we comfortable in this? Good. Now, again, relate to your day-to-day events. Now, whichever part of the country you are living in, north, south, east, west, central portion, wherever, every summer season, you experience a high temperature. But is it the case that every summer season, the temperature that you experience is the same? Or is it the case that sometimes the summers are very hot, sometimes the summers are less warm, sometimes the winters are very cold, sometimes the winters are cooler, moderate? So, is there a consistency in temperature that you observe, or is there a variation in temperature year after year? What do you think? Obviously, there's a kind of a variation, right? You don't experience the same temperature every year. Few of the summers you feel that this, every time you hear the elderly people speaking about it, that this time the summer is intolerable and this time the winter is also intolerable, right? So despite the same factors of heating and cooling, it is possible that different regions experience different temperatures every year. It is absolutely possible because you have movement of wind, solar insolation, evaporation rate, precipitation rate, all of them, ocean movement, all of them are responsible for the temperature that you experience in an area. So the temperature does vary. Now, let us put our focus in the region around 30 degrees. That is where you have the high pressure, the subtropical high pressure. Those of us who are not very aware about that, subtropical high pressure belt is present around the region of 30 degrees. Now, when we talk about the region of 30 degrees, let's suppose now this is a region where ideally you have a sinking air column, where the air is sinking below. And that is why 30 degrees is a region of high pressure, a thermal, not a thermal, but a dynamic high pressure, right? You have a dynamic high pressure. This is where the winds get supplied from. The trade winds and even the westerlies, they originate from the region of 30 degrees. Now, 30 degrees is still the region of the tropics. The amount of heat received in this region is always going to be very, very high, isn't it? So, just like in the region that you are living, in whichever state you are living in, it happens that sometimes the summers are extraordinarily warm. Here also, what happens is that sometimes the summers or the heating is very high. Now, in case, let's suppose the temperature experienced is very, very high in this area, the ground surface will get heated up despite the sinking air. The ground surface will get heated up. I hope we are comfortable up till this point. So, sometimes due to heating at around 30 degrees, the ground surface will rise tremendously. Now, when the ground surface heats up, what happens to the air parcel immediately in contact with the ground surface? This will also heat up, right? Because of conduction, the ground surface has heated up, so the air above it will also get heated up. Now, when the air gets heated up, its propensity or its normal tendency is to rise up. Whenever the air gets warmed, its normal tendency is to rise up, isn't it? So this air, it will be a futile action even though, but this air will try to rise up. There you have a sinking air column from the upper atmosphere. And meanwhile, this air is trying to rise up. While it won't be able to successfully create a low pressure in this region, but what about the dynamic high pressure which was in existence? Earlier, at 30 degree, you only had the sinking air which was falling down with a substantial amount of force, right? Creating that high pressure. Still, you have that air maybe somewhat falling, but now you have a rising air column also. So, what about the intensity of high pressure at 30 degrees? Will the high pressure get stronger? Will the high pressure remain unaffected? Will the high pressure get weaker? What do you think? Very good. The high pressure will get substantially weaker because rather than the surplus of air falling on the ground surface, now you have the air which is trying to rise up. It is encountering the sinking air, but still that high pressure will substantially weaken. Maybe for a brief duration, they will disappear as well. So, as that impact happens on the high pressure, what happens as an impact on the trade winds? These trade winds, they will also weaker the high pressure. Weaker is the wind. If the high pressure disappears, the wind also disappears temporarily, isn't it? So the trade winds, they get weakened and maybe they will even disappear. Now remember, I told you that in the case of the bucket example, that the winds are leading to the pile up. If I switch off the fan, all that water will flow back. In the case of the Pacific Ocean, it is these trade winds which are leading to the pile up. So if these trade winds, they weaken or they disappear, what will happen to the accumulated water in the Western Pacific? It will flow back. Flow back where? To the central, to the eastern portion of the Pacific, isn't it? So all that water will now start to flow back. So now, here, let us look at this situation. Are we comfortable up till now, my dear friends? Is there any issue up till now? I hope we are able to follow this. Okay, good. Because this explanation you won't find in the books. So that is why kindly try to follow. Now, ideally, the winds under normal conditions of Walker circulation, etc., basically, the trade winds would have carried everything. And they have led to a kind of a larger accumulation of warm water in this area. Now, what we are saying is that because of the heating which has happened in this particular year or maybe previous year, the subtropical high pressure belt in itself has weakened, and in maybe in certain patches it might have even disappeared, right? So there the trade winds will weaken or the trade winds might even disappear. So if these trade winds they disappear or they weaken, then what will happen to this piled up portion of warm water? Now it is simply an accumulation. Now this piled up portion of warm water will initiate a kind of a flow back. Depending upon how much water was piled up, it will flow back. It might even end up accumulating all the way across the region of Eastern Pacific. Right. So the warm water which was present here has now actually moved back. And you have the presence of warm water which is spread over. In this area, due to the flow back, the warm water has accumulated here. Not accumulated, but rather flowed back. Now, this is a region where you have warm water, right? This is the region where you have the presence of warm water. Now, warm water means a thermal low pressure. Weak or strong, regardless whether it is a strong low pressure or a weak low pressure, but there will be a low pressure because you have warm water. Now, what this will do is it will start attracting the winds towards that region of low pressure. Right? It will start attracting winds towards the low pressure. Now, as the winds are now getting attracted from here, what do you think will happen across the Western Pacific? The surface water will be carried by the wind now, right? The surface water will be dragged by the wind. So the subsurface water will rise up here. So here you will have the subsurface water which will rise up due to upwelling events. So here you have lower temperature or a comparative high pressure. Here you have a comparative low pressure. Winds will blow from a high to a low. So the winds will blow here. They will come to the region of this high pressure, low pressure. The winds will rise up. As they rise up, they will form clouds and they will bring rainfall across the Peruvian coastline. After all, that is what the fishermen reported, that suddenly you have Peru, which ideally should be dry, the western coastline has suddenly received rainfall. And this circulation will be carried out. Now, what is this circulation? Can we say it is a reversal of the normal Walker circulation? What we experience under normal Walker circulation, this is a reversal of it, right? Now, in this case, the Peruvian coastline will receive rainfall. Australia, Northern Australia, Indonesia, etc., will be very dry. So very dry that they might even experience the occurrence of wildfires or bushfires. Right? You have these frequent occurrence of wildfires and bushfires in Australia every few years, where due to very dry conditions and you have the summer season, obviously absolute lack of rainfall, the dry timbers and the trees, they catch fire. So that is because you have a high pressure in that area. Why do you have a high pressure in that area? Because the winds are blowing across the region of Western Pacific. They are carrying the surface water away. But why are the winds moving in that direction? Because all the warm water is now in the Central and the Eastern Pacific. But why is all the warm water in the region of Central and Eastern Pacific? Because there has been a flow back of water which was accumulated in the Western Pacific. But why has there been a flow back of water from the Western Pacific to the East? Because the trade winds have weakened or disappeared. But why have the trade winds weakened or disappeared? Because the subtropical high pressure region has got excessively heated up, and that is why the high pressure, which is the supplier of these trade winds, they have weakened or disappeared. Right? So this is where the entire Walker circulation system gets reversed. And this is a condition which we refer to as El Nino. Okay? I hope that makes sense. So during El Nino, basically, under normal conditions, you observe that you have strong winds, strong trade winds, which are accumulating the warm water. And eventually, in El Nino stage, all of that starts flowing back, isn't it? So That is what you have as the El Nino circulation. So, due to the weakening of trade winds, the accumulated water across the Western Pacific starts to flow back, leading to redistribution of warm and cold waters. Due to this, there are changes in weather conditions leading to drought-like conditions near Australian coast while causing floods near the Peruvian coastline. Okay, so that is the El Nino condition and the circulation that it initiates across the globe. Here you observe this. Observe how now you have a larger spread of this warm water. That is why El Nino conditions are also known as the warming phase of the Pacific. Warming phase of Pacific. Okay. Now, with climate change happening, the sea surface temperature rising, the warming phase of Pacific is becoming much more common, much more frequent. That is why we are experiencing frequent El Nino also. So here, observe you have the sinking air column, you have the conditions of high pressure here, right? Now, here you have a rising air column in the region of Western Indian Ocean. So under these normal conditions, under the conditions of El Nino, out of Arabian Sea and Bay of Bengal, which is most likely to witness the formation of a tropical cyclone? What do you think? Good. It will be Arabian Sea, because generally here you will have a pre-existing low pressure system which can get into existence. So Arabian Sea will have a greater propensity for formation of a tropical cyclone. So under neutral condition, Bay of Bengal will experience cyclones more often. Under La Nina conditions, again Bay of Bengal will experience cyclones more often. Under El Nino conditions, there is a greater probability of formation of tropical cyclones across Arabian Sea. Not that Bay of Bengal will not develop cyclone, but greater probability is there for the cyclonic formation. Okay. Now, El Nino basically reduces or leads to reduced amount of rainfall in India. We do know that El Nino causes reduced amount of rainfall. The reason of that we will study tomorrow. So when we talk about the El Nino and the Indian monsoon, observe here that this is an year-wise analysis for 10-year period. 2004 was an El Nino year. India received only 88% of the average expected rainfall. 2005 was a neutral condition where we had normal rainfall around 101% of the expected amount of rains. 2006 was again the neutral condition where we received 103% of the normal rains. The situation swung to La Nina condition in 2007 where we received around 110% of the average expected rainfall. But observe from 2008, the oscillation had started swinging. It was still La Nina, but its impact was slightly less. India received around 105% of the rains. 2009, El Nino, severe drought, very dry conditions, 79% of rains. It led to large amount of farm losses. 2010, it swung back to El Nino and you had 100% of the rainfall. 2011, La Nina persisted again. You had 104%. 2012, mild El Nino, 92%. Neutral, 2013, 106%. Right? So that is why we do know that El Nino leads to a reduced rainfall in India. La Nina leads to an increased rains in India. 2023 and 2023 is basically an year of weak El Nino. 2024 is expected to be an El Nino year, which is going to get stronger El Nino. So next year, again, we are staring at deficit rainfall. Now, meanwhile, 2022, 2021, and 2020, all these 3 years, we had the simultaneous or the consecutive occurrence of La Nina. And that is very rare. Generally, La Nina conditions will prevail for 1 year or 2 years, but generally not for 3 years. Right? That is a rare phenomenon, and that is what we also refer to as triple dip La Nina. Triple dip La Nina. When you have consecutive La Nina conditions existing for 3 consecutive years, right? So now it has swung back to the condition of El Nino. Okay. Now let us take a look at the question which was asked from this particular topic. Be very careful when you read the question. And the question is, La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? So, La Nina is characterized by, so read the question statements carefully and then get the answer. I'll give you 1 minute for this. Shalu, what do you want me to write here? And Surya, but shouldn't tropical cyclone in Arabian Sea balance this deficit? No, Surya. Basically, when we talk about the tropical cyclones, they create a rainfall in small areas. And that is also temporary for 1 week or so. That cannot balance the average annual rainfall deficit which is experienced in an area. Never. Anjali, incorrect. Nikhil, sometimes there is a heavy rainfall. Uh, sometimes there is a heavy rainfall in the areas where there is less rainfall or no rainfall in India. It is different. Indian monsoons are different. Good. Good number of you have given the correct answer here. Komal, sir, please tell an easy way to comprehend today's topic. Komal, I don't want to beat up the drum here, but trust me, go through various different books if you want, all the various different books. This is the easiest kind of explanation that you will find. The flow back, the bucket example, you don't find anywhere. Either the books will deal with an aspect where they will simply tell you that El Nino, you know what El Nino is? Low pressure in Australia, in the region of Peru, high pressure in Australia, rectify it, memorize it. Or the books will tell you, you know what is Walker? This is Walker circulation, reversal of Walker circulation, El Nino, intensification of Walker circulation, La Nina. So if you are good at that, a kind of a rote learning aspect, it will, then you can always go through any kind of a book. Or if you want to understand that carefully, please revise this or listen to the recordings, which I would suggest, at least for this particular module and for the module of Indian monsoon. After that, you are free to read any particular book, any book across the world that you want. But for these two, I understand the level of confusion that is created in the mind of the candidates, the level of, because the candidates, they hear about these terms El Nino, La Nina so many times in the newspaper. They think about it that the explanation would be that, you know what, Pacific is like this is El Nino, Indian rainfall reduces. But when they find out it is slightly bit complicated, you have upwelling, downwelling, accumulation of water, rising up of water, that is when they simply lose all their bearings. So that is why, again, I would recommend you that look at the session for today. We have had 1.5 hours of lecture. Revise it. There is no reason why you should not understand. Okay. And in fact, I would even go a step further and I'll tell you that the books, they don't do justice to this topic. Never. And neither do the newspapers, by the way. So here, La Nina is suspected to have caused recent floods in Australia. How is La Nina different from El Nino? La Nina is characterized by unusually cold ocean temperature in equatorial Indian Ocean, whereas El Nino is characterized by unusually warm ocean temperature in equatorial Pacific Ocean. Is that statement correct? Absolutely not. We have not even mentioned Indian Ocean till now. So just by replacing this term here from Pacific to Indian, UPSC has played the trick, and many of you have fallen to that trick. This is what UPSC expects the candidates to do, right? That the entire statement is almost correct if you replace Indian with Pacific. That is what happens due to lack of concentration. Please keep that in mind when you solve the multiple choice questions furthermore. El Nino has adverse effect on southwest monsoon of India, but La Nina has no effect on the monsoon climate. That is incorrect because La Nina leads to increased rainfall. So which of them are correct? The correct answer is going to be D. Okay? Right? Now, uh, there is nothing such mentioned in the books about these topics. I agree. Right? Now, after this, we'll come to the portion of Indian Ocean dipole. But before that, we take a break and then we come back and we start with this particular topic. So let's take a break of 10 minutes and then we'll come back. I'll answer your question, Sham, after the break. And we'll carry on with the portion of Indian Ocean dipole. In Indian economy subject, there was also a small, but in Indian economy, what do you discuss? El Nino condition, low rainfall, crop failure, falling rural demand, the national GDP falls. That's it. But why that El Nino? Nobody covers that. That is why we have to cover this. Anyways, let's take a break and be back in 10 minutes. Shalu, in La Nina, drought-like situation occur over Peruvian coast and flood-like situation occur in Australia region, whereas this condition is reversed in El Nino. Yes, that is correct. Chetri, what happens to El Nino condition if trade winds again become strong? It gets diluted after that. Then after that, the conditions of El Nino are not prevalent anymore. Nikhil, in the Indian monsoon, El Nino and La Nina effect is decided by the effect of Pacific areas effect, or is it different? We'll talk about the impact on Indian monsoon tomorrow. Uh, Sham, you had a question that if the rainfall which occurred in this, is it convectional or tropical? It is a convectional rainfall. And the other question that you had is that water really travel back thousands of kilometers? Yes, absolutely yes. Water, in fact, as we will study in the next couple of modules, that water ends up traveling for many thousands of kilometers. In fact, every few years, you have the water of all the oceans basically mixing with each other. So the water of Pacific will end up circulating with the Indian and the Atlantic Ocean, and this entire circulation takes place over a period of 1,000 years. But when we talk about ocean currents, they also travel thousands of kilometers, so they do. Now, do El Nino and La Nina occur at poles? No. And why everything happening in Pacific Ocean affects the condition in Indian Ocean and not vice versa? Because Pacific Ocean being a larger one, that initiates a kind of a larger circulation pattern and a much more sustained pattern in the atmosphere, which you don't find in the case of the Indian and the Atlantic. On the equatorial low is intensify, can we say that the wind speed increases? Yes, if the equatorial low becomes stronger, and you need to have a high pressure also, then you can have the wind speed faster. Why is El Nino and La Nina are occurring more frequently? El Nino is occurring more frequently. It is not as if both of them are occurring more frequently. That cannot be the case, right? It cannot be that earlier you had El Nino and La Nina, now also you have El Nino and La Nina. El Nino is occurring more frequently because of the conditions of global warming. Due to the conditions of global warming, the sea surface temperatures are rising up, and that is where the warming phase of the Pacific is also experienced. Okay, and is El Nino a reversal of La Nina or Walker circulation? Walker circulation. Is the similar condition as La Nina in Indian Ocean cause desert in Australia are created because of the cold ocean currents? Chandrajyoti, you have had a long time issue with the Victoria Desert, that why Victoria is a desert. If this, it is because of the cold ocean currents. Does the Walker cell observe only across the region of equator? Yes. Um, Flooding of eastern coast of Africa in El Nino this year is due to the low pressure in the, not exactly in the Arabian Sea, Rohit, but in the region around the western part of Indian Ocean. You have that low pressure due to which you have excessive rainfall in that area, and that is what causes flooding. Don't we have phenomena in Indian Ocean like El Nino and La Nina? We are coming to that, Udesh. And in which month does El Nino occur? So the events of El Nino and La Nina, they become frequently or predominantly much more felt during these months. November, December, January, Feb is when they get stronger in the southern summers. That is when they get stronger. They will have their impact through the year also. El Nino occurs in, so Dhyan, I think that answers your question also. Difference between Lal Nino, I like that spelling because it is neither El Nino nor La Nina. Lal Nino and Walker circulation. If you are asking the difference between La Nina and Walker circulation, La Nina is an intensified form of Walker circulation. If you are asking about El Nino and Walker circulation, El Nino is a reverse form of Walker circulation. But please don't write Lal Nina. Lal Nino rather. What is that is a very weird spelling. And how subtropical high pressure heated and weaker the trade winds in the conditions of El Nino, because in certain years you have increased amount of heating. That is why I told you that in whichever region you are living in, not every year you have the same conditions of summer. Sometimes you experience greater heat, sometimes you experience lesser heat. Okay. Ga- It is said that a cyclonic low pressure attracts winds, means motion of air towards low pressure, but the trees on ocean shown as influenced by a wind from cyclone to beach. Whoa, that question suddenly got very serious. Trees on ocean. Where do you find trees in the ocean, my dear friend? It is said that in a cyclone, low pressure attracts winds. Fair enough. I am with you till this point. Means motion of air towards low pressure. I am here with you till this point also. But the trees on ocean shown as influenced by a wind from a cyclone. Okay, okay. See, I'm actually not as smart as you guys, so I need a kind of a lower level English to digest that. So please try to tame down your English vocab and the grammar part of it. But I basically have now assimilated what you have tried to convey. If I'm not wrong, your question galaxy is good name that is also. So your question galaxy is basically the image that you had seen in the case of the tropical cyclones, where it was shown that on the beaches the trees were actually moving with a strong wind, right? So you are saying that if the tropical cyclone is formed in the ocean, why is it that the beaches get impacted? I hope I am correct. So if that is your question, please understand, if let's suppose this is the Indian coastline, let's suppose, now if a cyclone is developing here, this beach will not be impacted at all. If the cyclone comes here and is present here, the wind motion will be very significantly faster felt in all these areas. The winds will have a kind of a circulatory motion. So that is when you experience heavy rainfall along with the strong wind motion. That is why it happens. Okay, I hope that makes sense. Now, is that the change in tropical high pressure is the root cause of these changing events? See, understand why is that the tropical high pressure region experience that change? Because of heating. So heating and cooling is the root cause of all these events. Why do trade winds weaken during El Nino, Aditya? Because the subtropical high pressure belt weakens. Shabir, not only with the cyclones, La Nina and El Nino, even with the Himalayas, also rains falls. Not only with the cyclones, La Nina and El Nino, even with the Himalayas, also rains falls. Okay, again, see, it is very difficult to understand this. So if you are asking a question that rainfall happens because of the Himalayas also, yes, Himalayas are an important factor which leads to occurrence of rainfall, right? Okay, and all the other factors will come to Indian rains, and we will rainfall hampered due to Himalayas also. Yes, Shabir, absolutely yes. So Himalayas, as I told you yesterday also, that if had Himalayas not been there, the Indian region would have been a desert, right? Across the similar latitude, you observe the deserts. The Balochistan Sindh region of the Sistan Balochistan region of Pakistan, Iran area. Then, when you consider the region further, Daste Lut, Daste Kavir of Iran, Rubal Khali Desert of Saudi Arabia, then Sahara Desert, if you take a look at it, Sinai Peninsula, or Negev Desert that you observe, all of these are very, very dry. Then, further, if you go to the North American region, there also you have the Mojave Desert, you have the Chihuahua Desert. All of these are basically deserts. So, at these latitude, the regions are desert. The only reason India is not a desert is because of the monsoon phenomena. And that monsoon phenomena brings rain in India due to the existence of Himalayas. Had the Himalayas not been present, southern part would have received rainfall near the coastline, and the northern part would have been very dry and desert. Okay, Sierra Nevada, there you have the Mojave Desert. Yes, Indian desert is the Thar Desert is very small. Ideally, the conditions or the location of India is such that from the region of Rajasthan all the way till West Bengal, you have the ideal conditions for the existence of a desert. right? Ideally, it should have been a desert had the Himalayan region not been there. And we'll study about it tomorrow, that why it is not a desert. Now we come to the portion of Indian Ocean dipole. Dipole means opposite polarity at the two ends of the Indian Ocean. So we do know that Pacific Ocean is very large. So that is why the wind movement being very strong, it carries surplus amount of surface water, not surplus, but surface water is carried, accumulated in one portion. There is upwelling which happens in another portion. So that ends up creating a kind of a temperature and a pressure difference. Indian Ocean, even though not as large as the Pacific, there also, the two ends of the Indian Ocean around the region of equator, slightly to the north of it, Indian Ocean, the two ends, that is the African coastline and the Indonesian coastline, more particularly the Somali coastline in Africa and the Indonesian coastline in eastern portion of Indian Ocean. Both of them, they sometimes experience a difference of temperature which might be as less as zero point 0.2 degrees Celsius. It might be as much as 0.5 degrees Celsius, or it can even be 2 to 3 degrees Celsius. But as the two sides, that is the eastern and the western ends of the Indian Ocean, they indicate a difference in temperature. There also, within the Indian Ocean, you have a smaller circulation which gets initiated, and that is due to the Indian Ocean dipole. Dipole means the two poles indicating different conditions. So here, what do we mean by the two poles? You have the western and the eastern coastline, each of them indicating a difference of temperature. Now, when we talk about this Indian Ocean dipole, why is it that the eastern and the western coast will end up gaining different temperature? In the case of the Pacific, it was the trade winds which were blowing, which basically brought about warmer waters in the Western Pacific. So that is why you had the difference in temperature. But what about the Indian Ocean? First of all, you have to keep one thing in mind, and we will elaborate upon it much better tomorrow also. That is, unlike the Pacific, in the Pacific around equator, you have the ITCZ which is consistent. Unlike the Pacific, in Indian Ocean, ITCZ does not always lie at equator. ITCZ is not continuous at equator in Indian Ocean. Why? Because during the summer season, the ITCZ passes through the northern part of India rather than the equator. So that is why trade winds over the Indian Ocean, they are not as consistent as you observe over the Pacific. So here, trade winds are not a very important factor in terms of two ends of the Indian Ocean gaining different temperature. So what are the factors? Amongst the factors are solar insolation, wind pattern. Now what about solar insolation? Isn't it that at equator solar insolation is expected to be the same? It is. It is expected to be similar. And by the way, we are talking slightly above the region of equator. Now, in the region, for example, if you consider eastern portion of Africa, the region of Somalia, Eritrea, Djibouti, that area, the Horn of Africa as it is referred to. Now, that Horn of Africa, along with the Arabian Peninsula, sometimes gets extraordinarily heated up. When they get heated up very significantly, let's suppose the land gets heated up very significantly, by conduction, the water nearby will also start getting warmed up, isn't it? Sometimes the region of Indonesia gets heated up. So the water there gets heated up. So it is primarily because of that temperature difference created due to the insulation factors, the heating of the land, etc., which creates a slight temperature difference at both ends of the Indian Ocean. That in itself initiates a circulation between the eastern and the western Indian Ocean. And that is what we refer to as the circulation because of Indian Ocean dipole. By the way, before I tell you about the details of it, the heating cooling aspect, I hope we are aware about the fact that when we say Eastern Indian Ocean, we do not refer to Western Pacific. Many of you have the kind of a tendency to mix both of them together. That Eastern Indian Ocean means Western Pacific only. If I throw a stone, I have so much power, I will throw it all the way to Western Pacific. But the eastern portion of Indian Ocean is said to be the region up till Indonesian islands. And you have 1,000 kilometers away the region of the Western Pacific. In between, you have the small seas between the islands. Okay? Now, let us take a look at this. So, Indian Ocean dipole is called the El Nino of the Indian Ocean. The Indian Ocean dipole is defined by the difference in temperature between the two areas or the two poles of the Indian Ocean. Of the Indian Ocean, a western pole near the Somali coast, Western Indian Ocean, and an eastern pole in the Eastern Indian Ocean, to slightly to the south of Indonesia. Now, IOD is a sea surface warming phenomena with different regions of Indian Ocean heating to different degrees because of properties of the nearby landmass. When the land gets heated up, water gets heated along with that. Heating of land causes heating of water also. Prevailing wind patterns, oceanic circulations, all of them, they play their role in terms of different temperature. This induces a thermal pressure difference across the eastern and the western end of the Indian Ocean, which in turn initiates atmospheric circulations. And also, this is important, the atmospheric circulation initiated by the IOD also influences the impact of ENSO cycles across the Indian Ocean. What that means is that in the ENSO condition, we had seen that there is a circulation which exists over the Indian Ocean also. But if the Indian Ocean surface temperature in both the ends, they are different, that can initiate a cycle or a circulation, obviously much larger, that can initiate a kind of a circulation which will which can counteract or complement the already existent ENSO circulation. So it can tinker with the ENSO circulation. Now, positive iod, when we talk about IOD basically also has got three different phases, right? It has got the neutral phase or the normal phase. It has got the negative phase, and it has got the positive phase. Here also, the conditions, they keep on varying between normal to sometimes neutral, to negative, to sometimes positive. Now, again, I will reiterate that the details of how it influences the rains in India, we will talk about tomorrow, that why it influences the rains in India. But here, just for your awareness, this normal and negative, both these phases are basically concerned with less rains in India. And when we say positive, this is associated with higher rains in India. Right. So, positive IOD is a condition when you have higher amount of rainfall in India. Negative and normal is a condition when you have less rainfall in India. So, if let's suppose you have El Nino in the region of Pacific Ocean and you have a negative condition of IOD, so both of them will complement each other. So, India will receive very, very little amount of rainfall. If suppose you have La Nina and positive IOD, India will receive excessively high amount of rainfall, very heavy amount of rainfall. If let's suppose you have the condition of El Nino and positive IOD, both of them will tend to cancel out each other. India might receive normal amount of rains. So that is why it will always end up counteracting each other. Now, then what is the normal condition? And what is the negative condition? What is the positive condition? First of all, it is important for us to understand the normal conditions. Under normal conditions, what happens? So, when we talk about the Indian Ocean, the Eastern and the Western Indian Ocean, take a look at the portion of the Eastern Indian Ocean here. Now, here you have thousands of small islands, right? Thousands and thousands in numbers of the small islands. So, here, what is the dimension of it? When we talk about, let's suppose these islands, the water body is actually in between these islands, right? This is, you have the narrow and the small seas and the ocean, Indian Ocean waters in the Eastern Indian Ocean. That is basically trapped in between these islands. Now, you have many of these thousands of islands. So, will the water be able to circulate easily between them? Obviously not. Water will not find an easy way of movement. So, if the water remains stable and static in the same portion, in the same area, there is not much of a circulation. What will happen? The same region will continue to receive that solar heat, solar insolation, right? And water won't be able to circulate because it is stuck between the islands. So the water temperature in that case starts to rise. So in this case, temperature starts to rise. Okay. So as the water temperature starts to rise, the Eastern Indian Ocean generally, on an average, is warmer. That is what is referred to as the normal condition of Indian Ocean dipole. So, under the normal condition, what you actually experience is, or again, so under the normal conditions, you will observe that the water in this area gets comparatively warmer because it is stuck between the islands. The islands will also get heated up, and the water is not circulating, so receiving the heat in that same region continuously. So that is where you have a slightly higher temperature in this Eastern Indian Ocean. Now, when you have a slightly higher temperature, means what? It will start attracting winds. The winds will come here. These winds will then rise up. As they rise up, they will form the clouds. These clouds will cause copious amount of rainfall in this area. And then as they rise up, they will diverge. Meanwhile, as this wind is blowing in this direction, across the eastern coast of Africa, what do you experience? You will experience upwelling to happen. Colder subsurface water will come up, isn't it? So this is where the colder subsurface water comes up, creating a comparative high pressure, and you have a comparative low pressure here. So there you will observe the movement of the winds happening in this area. Right. So in this normal condition, this is your normal condition. Normal conditions, under normal circumstances, what prevails? So this is your normal condition where you will have the low pressure in the region of Eastern Indian Ocean. Why do you have low pressure in the region of Eastern Indian Ocean normally? Because you have so many thousands of islands. In between that, you have the water which gets accumulated, and or rather water is not able to move freely. So water in the same region gets heated up continuously, and that is when it starts gaining temperature, and that is when the water in the eastern Indian Ocean gets warmer in comparison. This will attract winds. The winds will cause upwelling in the region of western Indian Ocean, creating a comparative high pressure. So this is where you have normal conditions. As I told you, over the region of Indian Ocean, equatorial Indian Ocean, trade winds are not very consistent because the ITCZ keeps on shifting. And even if you have the trade winds which come to the region of equator, that is only for a few months of the year. It is only during these months, that is December, January, February, when the trade winds will be moving up till the equator. But otherwise, the trade winds never end up in the region of equator around the Indian Ocean because of the shifting of the ITCZ. Nonetheless, so in normal condition, what do you have? Warmer waters in eastern Indian Ocean, colder water in western Indian Ocean because of upwelling. So you have a comparative low pressure. Here you will have a comparative high pressure, right? Why? Because the winds which are blowing to the east, they would have caused upwelling here, and that is why they would have created a high pressure in this area. So this brings about a west to east circulation of wind pattern in the central Indian Ocean, causes a west to east circulation in Indian Ocean. Now this basically normal condition does not help rains in the Indian region or in Indian subcontinent. It is not good for rainfall, associated with less rains in India. Okay, so that is associated, that is your normal condition. Now think about it for a brief moment. So when we talk about neutral phase, this is your neutral phase or your normal condition. This is your condition of a neutral phase where you have warm waters accumulated here, and because of upwelling, why? Because the wind will be moving towards that warmer water, so will cause upwelling here. So that is why you have a comparative high pressure. Now meanwhile, as this wind blows, it blows from the region of a high pressure to a region of low pressure here. Now, as it is blowing over, it will carry more surface water along with it, right? So, when it carries more surface water along with it, what will happen? The region of warm water will get grown significantly much more intense, right? They will have much greater accumulation of warm water, and more surface water being carried away means this region of high pressure will also continue to increase. It will get more predominant. So we can say it will be an intensification of these pressure cells. So what will happen to the wind pattern? The wind will get much stronger, because as the pressure gradient also increases, the low getting lower, high pressure getting higher, means the winds will be much stronger. They will carry more surface water, much more intensification of the low pressure, much more upwelling happening in the region of the Western Indian Ocean. So there will be an intensification of this circulation sometimes. That intensification of the neutral phase is what we refer to as the negative phase of the Indian Ocean dipole. So, negative phase is associated with the intensification of why area of low pressure and high pressure increases. Area of low pressure and high pressure increases because as the winds they continue to blow, they will continue to drag more surface water. Along with that, surface water is the most hottest portion of the tropical waters. Subsurface water is colder. So as the winds will drag more surface water, won't the area where the warm water is there, won't that increase? As more surface water is carried away, won't it be the fact that you will have more upwelling happening in the region of the Western Indian Ocean? I'm not talking about trade winds here. I'm not talking about trade winds. Why wind cause upwelling if it is not carrying warm water? Please. Okay. Understand it again. Basically, I understand what is required here. You need it to be written down. So, Indian Ocean Dipole. It follows the same fundamental, guys. There is a slight variation. Please open up your minds slightly. Under normal conditions, water in the region of Indonesia get warmer. Why? As water is trapped between thousands of islands, continued heating by the sun in the same place increases temperature of water. This creates a low pressure in eastern Indian Ocean. It is a thermal low pressure. Now, due to this thermal low pressure, it attracts winds from all directions. This should be understood by normal deduction, guys. It should not have been so much amount of spoon feeding. Don't get that habit in general for your preparation from all direction towards the low pressure. Winds attracted from Western Indian Ocean towards this equatorial low pressure carry the surface water, warm water along with that. This causes upwelling in Western Indian Ocean, creating a comparative high pressure in Western Indian Ocean. This induces a west to east circulation in equatorial Indian Ocean. This is the neutral phase. Is that now understood? Hmm. Yes? Do you need a written text like that for every particular portion? That is why you have the NCRTs. Okay? Please keep one thing in mind, always the level of discussion in the class is not dependent upon what the faculty says. Level of discussion in the class is always dependent on the students, right? So if you want, we can elevate the level of discussion to an extent where you will have a kind of an advantage. But if the approach is not good, then it is always better to restrict the level of discussion to a sub-pedestrian level, right? So basically, if writing everything is what is going to lead to that clarity, then we'll do one thing. We will change the modules in such a way. We'll put more written text in the modules going ahead so that this particular issue is not faced. No, that does not happen. Handwritten discussion rather than writing, so that it serves as your notes as well. You can get a printout of it as well. Fair enough, it is up to you. It is your journey. I won't comment further on that. It is up to you to analyze. Why won't trade winds affect the IOD? As I have been repeating this, Satya, multiple times, the trade winds are not continuous over the central Indian Ocean because of the fact that where is it that the trade winds, what is the destination of the trade winds? The trade winds, their destination is the equatorial Indian Ocean. The ITCZ is basically the destination of these trade winds. But the ITCZ in itself continues to shift over the Indian Ocean. During the month of, for example, during the month of April, May, June, July, August, September, October, November, the ITCZ, because of the heating of the Indian landmass, ITCZ lies over India. So how can you have the convergence of trade winds in that area? So because the ITCZ does not lie at the region of equator in the case of the Indian Ocean, because there is a nearby landmass, that is why the trade winds are not continuous in the region of the central equatorial Indian Ocean. In the case of the Pacific Ocean, you don't have a nearby landmass. That is why ITCZ tends to remain at the region of the equatorial Pacific. That is why you have the trade winds being continuous there. Okay, I hope that is understood. Can you use a green pen instead of red? Can you write on your own, my dear friend, about what you have understood rather than expecting me to write everything? So I think that will be a better case of that. Now, when we say about the neutral phase of this Indian Ocean dipole, it is where you have a low pressure in the eastern Indian Ocean, high pressure in the western portion of Indian Ocean. Over a period of time, as the winds continue to blow, more and more surface water will be carried over from the region of the central Indian Ocean, and more of this surface water will be accumulated in this area. So there will be an intensification of that low pressure which will happen. That intensification of the neutral phase is what is referred to as the negative phase of Indian Ocean dipole. So in this negative phase of Indian Ocean dipole, the pool of warm water tends to increase, so does the pool of the colder water also, because of increased amount of upwelling which is induced by the stronger wind pattern. This negative Indian phase of Indian Ocean dipole, that is also what is not basically conducive for Indian rainfall. So associated with less than average rainfall or less rains in India. Then after that, we have a completely opposite situation, that is a positive IOD. Now, this condition of positive IOD is created because of the heating of the eastern portion of Africa and the heating of the Arabian Peninsula. So whenever the region of eastern portion of Africa and the region of the Arabian Peninsula, whenever they get heated up quite significantly, that is where the water body near them also gets heated up in comparison. So that creates a comparative low pressure in this area, and that attracts winds from all different directions. So once you have winds coming here, they will basically cause upwelling in the nearby area, creating the subsurface water to rise up in the eastern Indian Ocean, creating a comparative high pressure there. So that basically induces a wind circulation which is opposite to the neutral and the negative phase. And that is what is referred to as the positive phase of IOD. So positive phase of IOD is basically associated, I'll write it down, don't worry. Positive IOD. I will fill up the PPTs with the text now from the coming days. So positive IOD is basically heating of Africa and Arabian Peninsula causes heating of nearby waters. This creates a low pressure which attracts winds, causes upwelling in eastern Indian Ocean. This basically is condition of a positive IOD, causes increased amount of rains in India. So that is why positive Indian Ocean dipole is associated with an increased amount of rainfall experienced over the Indian subcontinent, as compared to the negative and the neutral phase of Indian Ocean dipole, which is associated with less than average rainfall occurring over the Indian subcontinent. Now, as we have already seen that the positive or these IOD circulations, as has been written here, IOD circulations or the atmospheric circulations initiated by the IOD that can influence or counteract the impact of ENSO cycles over the Indian Ocean also. That is all that is required for you to know for the GS portion of IOD. So let us take this question and then we move on to the next topic. With reference to Indian Ocean dipole sometimes mentioned in the news while forecasting Indian monsoon, which of the following statements is or are correct? IOD phenomena is characterized by a difference in sea surface temperature between the tropical western Indian Ocean and the tropical eastern Pacific Ocean. An IOD phenomena can influence an El Nino's impact on the Indian monsoon. Which of them are correct? You have 30 seconds for this. Good. So the correct answer here is basically B. So that is 2 only. Why is it that the first statement is correct? IOD phenomena is characterized by a difference in sea surface temperature between the eastern and the western Indian Ocean. Here you have Pacific Ocean which is mentioned, and that makes this incorrect. So the first statement again follows the same kind of a confusing pattern where a word has been misplaced here. An IOD phenomena can influence El Nino's impact on the monsoon. This is correct. So the correct answer is going to be B, that is 2 only. Now, after this, we come to the aspect of the Madden-Julian oscillation or the MJO. Now, this is a concept which is very different than what you have studied till now. This is a concept which is still being worked upon, and chances are that the questions can be asked in the prelims, not in the mains. It will never be asked in the mains examination. That is something I give you as a guarantee, because this is still an evolving concept. Not much of it is known, but we do know that it influences the Indian monsoons and the rainfall caused in India. So when we talk about the conditions of El Nino or Enzo, when we talk about the conditions, for example, in IOD, we have observed that basically the different types of pressure conditions created at both ends that induces an atmospheric circulation. But here you have a circulation pattern which ends up traversing across the planet. It travels and traverses across the planet from a west to east direction, aided by the rotation of the planet. In the tropics, near the equator, you have this traveling pressure system just like a conveyor belt that you see in the factories, etc., where the goods basically are circulated, or in the escalator that you see. So similarly, as the planet keeps on rotating, you have a low and a high pressure system which basically travels all over the planet within a 30 to 60-day period around the region of the tropics. This was also associated with a kind of an accidental discovery, where you had these scientists with the name of Madden and Julian, who were basically in the region of Singapore, to study about the equatorial climatic condition of Indian Ocean and the amount of rainfall received around the equatorial areas. There, they actually stumbled upon the finding that around the region of equator, you have sometimes you basically have periodic rainfall, high intensity of rainfall, which occurs and then tends to repeat itself after every 30 to 45 to 60 days. And that is when they arrived at the conclusion that this is a different phenomena. This is a traveling pressure system, and that traveling pressure system was known as the Madden-Julian oscillation. So when we talk about an MJO or a Madden-Julian oscillation, it is an eastward moving disturbance of clouds, rainfall, winds, and pressure that traverses the planet in the tropics and returns to its initial starting point in 30 to 60 days on an average. Each cycle lasts for approximately 30 to 60 days. So if you think about it, you have the kind of a circulation here where you have a low pressure, where due to the low pressure you have rising air, and you have sinking air column next to it, creating the regions of high pressure. So this entire circulation system in itself traverses in a direction of west to east, aided by the inertia of the Earth's rotation. Earth also rotates from a direction of west to east. So that is one of the reasons why this circulation pattern also rotates from west to east. I'll write it down as well. So aided by Earth's rotation from west to east. That inertia, or inertia might be a too heavy a term, induces a relative motion for the wind patterns. That is why this also moves in a direction of west to east. So it occurs in the region of the tropics, generally around the region of equator. So that is where you observe this entire circulation where you have a low pressure system, that and here you have a kind of a high pressure system on both ends. You have a high pressure system here, and here also you have a kind of a high pressure system here. So that entire circulation happens from a direction of west to east. So this is basically a traveling system, and this travels in the entire part of the planet around the region of equator. Now, when we talk about these MJO, this appear to look like this, where you have a region of low pressure surrounded by two regions of high pressure. And this is the region of the low pressure is known as the region of enhanced rainfall, or convective rainfall is received in that area, very heavy amount of rainfall. And these are the areas which are sunny and dry because of sinking air. And these are the areas which are generally the regions of high pressure becoming dry, no rainfall is received. Now this entire thing basically moves eastwards. It comes into existence around the region of Western Africa, transitions over the region of Indian Ocean. Then you that entire movement transitions over the region of Pacific, and then eventually crossing the Atlantic, again returns back to the region of West Africa. So that is how the entire circulation, it can happen within 30 days, it can happen within 60 days, it can happen within 45 days as well. Whenever you have this enhanced rainfall phase or this low pressure phase lying in the region around India, that means you have high amount of rainfall received in India during the monsoon months. If you have that high pressure phase lying over the Indian subcontinent, then that means lesser amount of rainfall received in India. Now this 30-day or 60-day cycle, if let's suppose this repeats itself in a 60-day duration, means that you will not have that much great amount of frequent low pressure systems moving over India. So in a longer cycle means that this low pressure system comes over India almost after 2 months or 1.5 months. So not very good for rainfall. But if this is a 30-day cycle, means very frequently this will come over to the Indian subcontinent, which means very frequently there will be rainfall. So a shorter cycle of MJO is always beneficial for more rains in India. Shorter cycle of MJO is beneficial for rains over India. And the why does that happen? Because that means you have low pressure systems which come over India very frequently, and that is why you have more frequent amount of rainfall. So the MJO consists of two parts or two different phases: the enhanced rainfall phase or the low pressure phase, and the suppressed rainfall phase, or the high pressure region. But this is not static in a place. This keeps on transitioning, this keeps on moving eastwards. And the simple reason for that, if you have to consider, if you have to, nobody is going to ask you why this moves. Nobody is going to ask you what why this comes into existence, because it is still a kind of a global mystery out there. But some understanding we have. I'll not take you into that particular detail. I don't want to cause much trauma. So here, when we talk about this region, let's suppose you have the conditions of low pressure. Here, the winds come, they rise up. The winds come, they rise up. As they rise up, they form convective clouds in the region of low pressure. They cause a lot of convective clouds, and then convective clouds cause a lot of rainfall. This diverges. The air will sink somewhere after getting cooled down. This will be the region of a high pressure. This will again be a region of high pressure. So that is the circulation that you observe. Now it is aided by the Earth's rotation from a west to east direction that provides it the momentum to it to move in the west to east direction. Now here, what you observe is basically the fact that this low pressure system, here, this region receives rainfall continuously. Now, if that region receives rainfall continuously, what will happen to the temperature of that area? After receiving rainfall over a continuous duration, the temperature tends to reduce. It tends to become cooler. Whereas if you consider this region of high pressure, that is where you have no amount of rainfall. We are talking about the equatorial area, no amount of rainfall for a long period of time, absolute amount of sunshine. So that region continues to get warmer. So here, you have the high pressure region which continues to get warmer, the low pressure region continues to cool down. After a few days, this temperature will increase so much in this area that rather than high pressure, this transitions into low pressure. And the situation will get so cool here that rather than low pressure, they transitions into high pressure. So that would mean that the entire system has basically transitioned forward, because now the winds will start rising from here, and the entire system would have moved in a direction of west to east. So that is basically how the MJO transitions from one region to another. Now we come to the portion of jet streams. You provide 2 to 3 diagrams of one topic, out of which we should draw, depending upon what is required by the question. What kind of question is asked? Is MJO one of the reasons behind the greenery across mid-African country? Not so significantly, but less, yes. Rishika, why MJO is observed only around the region of equator? That is where you have a kind of a phenomena of low pressure which frequently develops owing to the thermal heating which is observed there. That is why no other portion of the planet will you find such frequent development of thermal low pressure. Thermal low pressure virtually is existent almost throughout the year in many parts of the equator. That is why you have the natural rise of air caused in certain pockets. And that is where you have a lateral fall and creating this kind of a circulation also. And how winds are moved west to east along with the rotation of the earth, it might be east to west direction, because if we dip a sponge round ball and rotate it from west to east, we can observe the water droplets move from east to west direction, right? Is it not the same for the wind direction? No, it is not that for the wind direction. Because when you are talking about the sponge ball and you are talking about the water is almost static in that case. But when we talk about the wind movement, many of the times the wind movement is further initiated But, or when we talk about the oceans, also in the Central Indian Ocean, there, or Central Indian, Central Pacific, Central Atlantic Ocean, there also, the rotation of the planet induces a slight circulation towards west to east around the region of equator. That is by the force of inertia. It is that inertial movement which induces that west to east motion. How MJO is different from Indian Ocean Dipole? Indian Ocean Dipole is a circulation which is found to be present only in the region of Indian Ocean. MJO is a circulation pattern which travels across the planet. Indian Ocean Dipole does not travel. MJO travels across the planet. It covers the entirety of the planet within 30 to 60 days. So you have a circulation pattern which is moving, you have a circulation pattern which is static. Indian Ocean dipole is induced because of temperature difference between eastern and western Indian Ocean. MJO is induced because of the low pressure, high pressure conditions and the traveling pressure systems across the entirety of the planet. So it is substantially different. And then Pile in the region of equator, continuous rain is going on, not in all the areas, in those areas where you have the convection process carried on, only in those areas. And which is more beneficial for the monsoon, the MJO or the positive phase of IOD? It depends upon the intensity, but the positive phase or the negative phase of IOD, when we talk about IOD, this continues to change very frequently. IOD doesn't have a particular season. Unlike ENZO, IOD doesn't have a season. So IOD can change on a weekly basis almost. That you have a positive IOD might be today, and maybe after a week you can be staring at a condition of a negative IOD developing or a neutral IOD developing. MJO causes an increased burst of rainfall over a short duration. IOD influences positive rainfall for a longer time period. So that is the difference. Uh, in the region of equator, continuous rain is going on. So I hope, Payal, I have answered that. Why there is change in low pressure to high pressure in the middle? Because that low pressure region gets heated up. That low pressure region continues to get continuous rainfall. Any area which it receives that continuous rainfall, the temperature drops. That is why. I'm very confused because somewhere you said we had rainfall in low pressure and somewhere you said that we have rainfall in high pressure. If I have said that, don't worry about it, forget it. Low rainfall will always occur in low pressure only. Rainfall will never occur in the region of high pressure. Keep that in mind. I was talking about the transition of low pressure to high pressure and transition of high pressure to low pressure. But if that confuses you, always stick to the basic. Rainfall will only happen at the region of low pressure. And how does Madden-Julian oscillation impact or affect the Indian monsoon? If you have this enhanced rainfall phase lying somewhere in the region of India, then that means increased amount of rainfall. If you have the suppressed rainfall phase lying anywhere close to India, that means reduced amount of rainfall. Is ocean current also a contributing factor to a low or high pressure? Yes, that is true. Okay. So now we move forward with the portion how IOD is opposite to El Nino. Who told you IOD is opposite to El Nino? Where are you getting these concepts? IOD is not opposite to El Nino. No. IOD can counteract the circulations of the ENZO cycles. When you have the ENZO cycles, ENZO circulations, they will have an extension of that circulation over the Indian Ocean also. But when you have Indian Ocean dipole, that circulation can counteract the circulation initiated by the ENZO cycles. ENZO and IOD, they are not interrelated to each other. But when it comes to amount of rainfall in India or the rains received in India, each of them can counteract their effect. MJO is convectional rainfall, yes. Okay. So now we move ahead and we talk about the portion of jet streams. When we talk about jet streams, these are basically very high altitude, very swift moving wind pattern. Komal, MJO, and IOD you don't find in the books. You will find it in, you can search it on Google. You will find various research pieces on that. So you can go through that. But in books, in reference books, it is not there. Now, When we talk about jet streams, these are very high altitude, swift moving winds, which are in existence in the region of the top of troposphere. These jet streams basically were a kind of an accidental discovery. Now, it was in the 1920s itself when you had a French climatologist who, with a balloon experiment, he launched a balloon into the upper portion of troposphere, where he witnessed a very strong and a swift movement of wind. And he was very certain that in the upper portion of troposphere, you will have a strong and a swift movement of wind, which is experienced. But the further research could not be carried out. Then, when the Second World War came into presence or came into existence, at that point of time, the US bombers were carrying bombing mission all the way into the region of Japan. Now, if you have to travel from US to Japan, you have to travel in a direction of east to west. Now, these fighter pilots, they witnessed something or they experienced something quite unique. They experienced that as they are moving from east to west, the airline speed or the flight speed tends to reduce. But when they are flying back home from a direction of west to east, the flight speed of the aircraft would substantially increase. They would report this particular event to the naval headquarters or the Air Force headquarters, rather. Now, these Air Force headquarters, they always have the climatologists in action. They noticed this, they thought about it to be an atmospheric anomaly. But a similar feature was also observed while carrying out the bombing missions over Europe. It was found out that if the plane movement is from west to east at a certain altitude, their plane moves with a greater velocity. And if the plane is coming from east to west, there's a reduction in velocity which happens. So that is when it was concluded that there must be a very strong wind movement in the upper region of troposphere, which can alter the speed of these jet aircrafts. And that is when the name of it was the jet streams. Now, these jet streams basically are columns of very high velocity wind moving in a particular direction, that is west to east direction in certain parts of the planet. Now, here, if you take a look at it, there are relatively narrow bands of very strong wind in the upper levels of atmosphere. The winds blow from west to east in the jet streams, but the flow often shifts north and south. What that basically means is that when we talk about these jet streams, they move in a direction of west to east, but this movement can shift north. This movement can also shift slightly to the south. So there can be this particular movement of this jet stream, north and south, with the variation of the seasons. They travel in the region to the top of troposphere, in the region of the tropopause, and they have a variation in terms of a height from 8 to 15 kilometers, in the sense that if you have this as the ground surface, the jet streams can have a transition like this, where let's suppose they have a great height here, they have a reduced height here. Here it can have a height of 6 kilometer. Here it can also have a height of 12, 14 kilometers, for example. Right? So there's a variation in terms of the vertical height. There's a variation in terms of the latitudinal positioning also there, where they have a wave-like pattern which is generated. Now here, when we talk about the shape and size of the jet streams, these are basically the strong air currents, and they appear to move like rivers of swift moving air in the atmosphere. And when we say rivers of swift moving air, here, just like as the property of a river that you observe, property of the river, what do you observe? That on the sides, the speed of the water movement is the slowest. And in between, the speed of water movement is always fast. In a similar manner, when we talk about these jet streams, there also, as these jet streams, they tend to move in a kind of a band-like pattern. In the central portion, the speeds can go in the excess of 300 kilometer per hour, can sometimes even reach 400 kilometer per hour in the central portion. Now, they tend to look like wavy, striated, or striped rivers when seen on jet stream map, from where cold air and hot air meet. So that is the formation of the jet stream. You don't have to go into the reason of it. The formation of the jet stream is initiated whenever you have the mixing or the meeting of the cold air and the warm air in upper altitude. That is what creates a temperature difference, which induces a pressure difference, which induces a strong motion of the wind pattern. So here, when we talk about the formation is created when there is a difference of temperature in upper atmosphere. This creates a localized pressure difference induces a swift movement of wind. So, as per the tricellular model of circulation, also what we have seen earlier is basically the fact that in the region of ITCZ, this is your region of ITCZ, you have winds which converge in the region of ITCZ, they get heated up, they rise up, and these winds, they rise up, they diverge in the region of the tropopause, the top of troposphere, and here you have the sinking air column at the region of 30 degrees, and there you have the divergence of the winds, which one portion goes towards the ITCZ, the other portion goes towards the subpolar area. There is in the subpolar area the rise of the wind pattern also, and that indicates a kind of a circulation that we have seen. Now, wherever you have a difference in the upper air temperature, that is where the jet streams are induced. So when we talk about this region, above the region of ITCZ, there you don't have any difference of temperature because both the winds are coming from the tropics. So both of them will have similar temperature, hence not much of a difference of a temperature over this. So no jet stream does exist over the region of ITCZ. You don't have any jet stream which is in existence. Having said that, when we talk about this particular area, over the 30 degrees, over the horse latitudes, over the subtropical high pressure belt, in this area, you have one of the winds which are coming from the region of equator, one of the winds which are coming from the subpolar area. So here you will have a difference of temperature. So in this area, you will have a jet stream which blows from a direction of west to east. Similarly, when we talk about this particular area, the subpolar low pressure belt, even above this, you will have a difference of temperature because you have one of the winds coming from the tropics, one of the winds coming from the poles. So as they rise up, there will be substantial difference in temperature, and you will have a jet stream in this area also. This is what is also referred to as a subtropical westerly jet stream. Westerly jet stream. This is what is also referred to as the polar jet. Similarly, you have these jet streams in the southern hemisphere also. Now, polar jet and the subtropical westerly jet, they basically are in presence because of the permanent wind system, because of the tricellular model of circulation. That is why these jet streams, they come into existence. And basically, the shifting of the pressure belts means the shifting of the jet streams also. We do know that the pressure belts during the northern summers, all of them, they shift to the north. During the southern summers, all of them, they shift to the south. So similarly, the jet streams also, they tend to shift to the north during the summers. They shift to the south during the winters in the northern hemisphere. Now that is about these jet streams. These are known as the permanent jet streams because they are induced by the permanent wind systems and they are in presence almost across the planet. They are also known as the permanent jet streams. So you have four permanent jet streams, two in the northern hemisphere, two in the case of the southern hemisphere also. So jet streams basically are stronger in winter. Why? Because these jet streams are created because of difference in temperature. And that difference in temperature induces a motion. So jet streams are stronger in winter in the northern and the southern hemisphere. That's when the temperature differences that drive them tend to be the most pronounced. Okay? Now, the actual appearance of jet stream results from complex interaction between many variables, such as the location of high and low pressure systems, warm and cold air, and the seasonal changes. They meander around the globe, dipping and rising in altitude or latitude, splitting at times and forming the circulation eddies, and even disappearing altogether or appearing somewhere else. That is the feature of this particular jet stream. They are created purely because of temperature difference. This is what they appear to look like. That is what these jet streams they appear to, or they give the appearance. Now, when we talk about this particular jet streams, Earth has got four primary jet streams. These are your polar jet and subtropical jet, both in the northern and the southern hemisphere. You also have the presence of the temporary jets. Temporary jets, just like the local winds, are in existence over a short area, and that too for a temporary duration of time. So here you have the examples such as the tropical easterly jet, which moves over the region around the portion of Asia and crosses over to the region of Africa. You have a temporary jet in the form of Somali jet, Siberian jet. These are examples of temporary jet streams, which are in existence over a short duration for a short time window. That is the case of this particular jet stream. Okay? Why up and down movement? See, I will tell you about the formation, but then you will have to write it on your own. I will simply not write about the process of formation. That is not an approach that I will carry forward. MJO, is MJO the same as Walker circulation? Aditya, my dear friend, if MJO would have been same as Walker circulation, if MJO would have been same as IOD, wouldn't have we mentioned that in the same topic? If let's suppose the concept is not understood, at least logic should be understood. What is MJO? MJO is a traveling pressure system. What is IOD? What is Walker circulation? Are we aware about Walker circulation, Aditya? What is Walker circulation? Let me know and then I'll tell you. So I'll tell you about the formation of the jet, but I'm not going to write in it. So all those who want those written notes, ready-made notes, you're free to write on your own. Formation. Due to temperature difference in upper atmosphere. How that leads to the existence of a jet stream or creation of a jet stream. Pay attention very carefully, again, not to be found in the books. So, Aditya, you yourself have given the answer, my dear friend. You have said that Walker cells are confined only to the western and eastern tropical uh, Pacific Ocean. But what is Walker circulation? A circulation which is induced in the Pacific due to different temperature. What is Indian Ocean dipole? The condition of sea surface temperature variation in the Indian Ocean inducing a circulation. What is MJO? A traveling system of pressure which travels across the planet. It starts from the region of, and listen to this carefully because I have been repeating this and you have also been repeating the question. So you are also as perseverant as I am. So for a brief moment, put your hands out of the keyboard or the mobile, wherever it is. Listen to this very carefully. When we say Madden-Julian oscillation, this is a kind of a traveling pressure system. The traveling pressure system of a low and a high pressure that basically is initiated in the region around Western Africa because of heating of the region of Western Africa. Africa, where is Africa? In between Indian and Atlantic Ocean, very different from the region of IOD and ENZO. In the region of Western Africa, you have that low pressure system which gets created. Wherever the air will rise, it will sink in different latitudes. Due to the Earth's rotation from west to east direction, there is a momentum provided, and then the low pressure area receives convective rainfall. High pressure region continues to remain dry. So the high pressure gets converted into a low pressure. Low pressure, because of excess rainfall, becomes colder, becomes a region of high pressure. So that in the first phase of MJO, it transitions from West Africa to the region of Western Indian Ocean or Eastern Africa. In its second and the third phases, that MJO crosses over the Indian Ocean, reaches over the region of the Pacific. In the fourth, fifth, and sixth phases of MJO, that basically traverses over the entirety of the Pacific. Then in the seventh and the eighth phase of MJO, it crosses over the Atlantic and then reaches the western portion of Africa. This entire eight phases of MJO can be completed within a period of maybe 30 days, maybe 45 days, maybe 60 days. So, again, in a nutshell, it is a traversing system or a traveling system of the pressure cells. Think about a conveyor belt. I hope we are aware about a conveyor belt. Conveyor belt basically means that you have a, or at least you would have seen in the malls, the escalator systems that you have, where you step onto it, that escalator goes up, comes back down, goes up again. You would have seen that. So think about that MJO as a kind of a traveling conveyor belt of the pressure across the planet. Whereas IOD and ENZO, they are fixed in their location of the pressure that is created. Is that understood? Does that make sense? Now, after this, we come to the formation of the jet streams. Now, here, when we talk about the jet streams here, let's suppose you have warm air. And then you have a region of cold air. Cold air will always have a lesser volume as compared to warmer air. I hope we are aware of that. Cold air will always have a lesser volume as compared to warm air. Warm air will always have a greater amount of volume. Now, on this region, what will be the condition of pressure here? High pressure or low pressure? What do you think? In this region, you will have high pressure. Underneath the cold air, you will have high pressure. Underneath the warm air, you will have low pressure. Let's consider the pressure at an elevation. The pressure at A and the pressure at B. Now, what will be the pressure at B? Above B, you find that you have a substantial column of air. Here you have very little column of air. So above B, you will find the presence of high pressure. Here, because the air column is almost negligible, here you will find the presence of low pressure. So the cold air, despite the fact that it has high pressure on the ground, when you go at a particular elevation, because it has got lesser volume, it will be indicative of a condition of a low pressure. The warm air, while it will have a low pressure condition on the ground, if you move up a particular height, it will indicate a condition of high pressure because it has got an expansive volume. So here you have a high pressure and a low pressure. Winds will move from a high to low always. So winds basically will be moving from this warm to the cold air. Now, if I replicate it onto the planet Earth, let's suppose, if we consider the polar air is going to come from this latitude, and the warm air is going to come from these areas. Now here, what is the motion here? Movement of the jets from the region of warm to the cold. Now when we are in the northern hemisphere, these will bend in which direction? These will bend in the rightward direction. So here, the movement which is initiated will be bending in the rightward direction. That is your jet stream. When we talk about the subtropics, let's suppose we talk about the region of the subtropics. Now in the region of these subtropics, here, in the upper atmosphere, upper altitude, what do you have? You have cooler winds coming from the subpolar areas, cooler winds coming from here in the upper atmosphere, and you basically have warm winds coming from the region of the ITCZ in the upper atmosphere. There also the jets will be moving from warm to cold but deviating to the right. That is why you have the west to east motion of the jet stream in between these particular pressure systems. I hope that is understood. Now, when we talk about these jet streams, as they move, as they blow, they have a variation in terms of height also. Why is there a variation in height, by the way? That is because not at every place will you find that the height of the warm air and the height of the cold air, they are not same. In certain areas, the cold air will be having much lesser height, warm air will be having much greater height. So that is when the air moves from surplus to deficit, high pressure to low pressure, it will have a kind of a vertical dip which will be observed. And also, in certain areas, the cold air will extend further south, warm air will extend further north. That is why the jet streams, they will represent almost a three-dimensional variation in terms of its movement. So that is why it has got longitudinal variation, or rather latitudinal variation also. It has got a vertical variation also. So in three dimension, if you want to imagine these jet streams, imagine as if it is moving, coming forward, dipping, moving up, going backward, coming forward, again dipping. So it is a three-dimensional variation. Now, these jets, they don't allow, or they don't tend to move wherever you have physical barriers such as the Himalayas, etc., in its place. So these jets, they don't move in those areas. These jets also don't allow the air from different areas to mix together, but that is the concept we will cover tomorrow. We will not cover it today. We'll cover it tomorrow about the impact of jet streams and the weather. We take up this question and then we will end the session. The question is, consider the following statements about jet streams, cyclones, right? So let's take up the question. Jet streams occur in the northern hemisphere only. Only some cyclones develop an eye. The temperature inside the eye of the cyclone is nearly 10 degrees Celsius lesser than the surroundings. I see all of you are falling for the trap that UPSC tends to create, that UPSC wants the candidates to fall in that trap. Most of you are falling in that trap only. But nonetheless, jet streams occur in northern hemisphere only. Incorrect. Jet streams will be present in southern hemisphere also. Only some cyclones develop an eye. That is true. Not all the temperate cyclones will develop an eye. Tropical cyclones will always develop an eye. So 2 is correct. The temperature inside the eye of the cyclone is nearly 10 degrees Celsius lesser than the surrounding. Eye of the cyclone is warmer than the surrounding. That is why eye of the cyclone doesn't have any kind of cloud formation also. The trick that UPSC plays is by mentioning 10 degrees Celsius. If let's suppose the statement had been temperature in the eye of the cyclone is warmer than the surrounding or colder than the surrounding, you would have stressed upon the fact that whether it is warm or cold. The moment UPSC mentions 10 degrees Celsius or 8 degrees Celsius, the mind basically thinks that, okay, this is a fact. This is a data oriented fact. This is the trick that UPSC tends to play. This entire basically thing is to masquerade the fact that in the eye of the cyclone, the temperature is higher. That is why eye is cloudless. So this is also going to be incorrect. The correct answer is going to be C. That is 2 only. So that is where we'll restrict the session here today. We come again tomorrow. We'll talk about jet streams and the weather. How do they influence the weather? And then we will move on into the portion of Indian monsoon. And we will carry on further. So that will be all from my side. Till we meet again tomorrow. Do take care of yourself. Thank you. Goodbye.